This is Coffee Compiler Club, and here to talk about compilers and language runtimes and language design and compiler guts and scheduling and SSA and everything else. You're recorded. You'll show up on YouTube, probably in a couple hours, and then I'm off for 2 weeks, flying to Europe to do 1 week of vacation and 1 week of teaching classes at summer school, VM summer school in Bernatoro in Italy, someplace in Italy that I'm not Italian, I can't say the name. Not too far from Venice and Rome, so we're going to be tourists for a little while. I have a little bit of agenda today, and that's that we've pushed off Simon like 3 times in a row. So, Simon, if you're interested, are you interested in showing what you've been doing?
Yeah, sure. Let's do it. Shall I share my screen, or do you want?
Yeah, just a second. Try it now.
Let's see.
And Alan is trying desperately hard to join us and keeps getting bounced. We'll see if he makes it in eventually.
Seems to work for you.
Yeah.
Excellent. So I've
no work-related pop-ups.
Hopefully, yeah. I guess I'll be reminded of that story for like the rest of the year. Which will not be that long anyway. But yeah. Well, at least we all learned how to edit videos with YouTube's.
What a mess.
Editor.
Fine.
Anyway, yeah, I'm working on this small minimal language called Core, and I did some small improvements in the last few weeks, and I thought maybe you're interested in some of the insights I gained, and maybe I can also benefit from some of your insights. The first thing was string hash caching. So basically what you would expect. Previously, the language had a string type that consisted of the length and of the byte array, or like a pointer to the start of some memory, and to use strings and hash maps and hash sets and so on. I thought it would make sense that strings had implementation for hash code, and on top of that, of course, I don't want to recompute the hash code every time I ask for it, but I want to compute it once and then store it in the string instance.
So the 36-bit length field surprises me.
Yeah, so basically what I started with was, let me see whether I can find a commit. So what I started with was basically a string header that had basically 64 bits. I'm ignoring 32-bit platforms, but yeah, 64 bits of length. And because
So strings a primitive, a basic type in the language.
Yeah.
Like in Java, strings are a constructed thing. They're in the language. They're not a primitive in the language.
Yeah, and they are not really a primitive, so there is a string class definition. It's just marked internal because there is some amount of magic going on.
Well,
so representation is special.
Because I was see 36 bits for length is unusual, and is there any reason not to just go back to 32 on the length and skip the 4 bits?
Yeah, I mean we would probably not have too much trouble with alignment, but yeah, so yeah, going back.
Well, no, I'm just saying for ease of dealing with the math that you end up generating for code computation and for understanding the semantics or whatever, when you go from 32, the jump to 64 straightforward, but an in-between jump has weird issues. Like your range checks have to deal with it, and you have to get the length by extraction as opposed to just loading it.
Yeah,
Like,
yeah.
okay.
Yeah, so one of the considerations was, okay, I'm just putting my hash field behind it, and then I had lots of alignment issues which were unrelated to that decision, but just cropped up because I didn't do it correctly. And that's when I basically said, okay, I'm not touching the layout. I'm just taking my 8 bytes and trying to trying to stuff things in there. And what I ended up with is that I used upper 28 bits as a hash, used the lower 36 bits as length, and with that I basically don't have to care about anyone realistically creating strings that are too big. I mean, that's like 32 or 64 gigabytes.
Instead, what will happen is somebody will hash every URL they ever saw over a large lifetime, and you'll have more than so many billions of unique strings, and 28 bits of hash will cause collisions. Yeah, Chris is asking why 28 bits of hash. You'll get collisions on 28 bits because of the sheer volume of unique strings that show up when people do shit like hash every URL on the planet. Having been there.
Well, I'm not doing Java hash code, so
Well, I'm not claiming
that
Java
implement
hash code.
not that
No.
bad.
I'm claiming you chop to 28 bits. I would claim you're more likely to want to have 32 bits of hash and 32 bits of length than 28 bits of hash and 36.
Right, and even for convenience, I would just go with 32. I mean,
Yeah.
you can still squeeze them into 64 bits. It doesn't matter.
Yeah, possible. I'm skeptical. I don't want to deal with people saying, okay, I created this string and it's 2.2 gigabytes of size and it doesn't work anymore.
No.
No,
So
what I wonder about, like, how did you come up with 28 bits? I mean, as Cliff said, it's a really interesting decision. 36.
When the Java community went down this path, because the original Java objects had a much shorter hash. They had 16, got pushed to 20 by squeezing bits out of the header, got pushed again to 28. I want to say we went to 28 for a while, and it all sucked. When you scaled up at some point, that sucked.
But the Java hash code implementation is just not.
No.
I mean,
the hash code for string sucks, but just having fewer bits of hash, like in my opinion here, hash does not belong in the object header. And then you can get away with, you can remove this problem altogether, because most things don't need a hash. Don't reserve it in the header. If you need a hash, you probably need 32 bits, but maybe you need 64. And that's a decision that the programmer makes. On rare occasion, there'll be a 64-bit, and then it's not your problem anymore. Get it out of the header. Separately, the length being 36 fucks with any range check math you ever want to do, and go to 32 or stick with 64.
You mean
I mean, the
the
implementation of range checks for
you mean regarding overflow, or just
every go do overflow underflow checking on range checks for when people say for I equals 0 to end of string, look for the following regex pattern.
Yeah, it seems like with 36 bits of length, you get all the disadvantages of having a weird aligned length, and you don't actually have enough bits that people won't overflow it anyway.
Yeah, if somebody's going to overflow 2 gigs, they're going to overflow 16. Like, no one overflows 2 unless they're just like out of control, in which case they're going to overflow whatever number you pick, unless it's far bigger than the number of address bits available on the machine's hardware.
Yeah, then I can give them another 2 bits. Maybe.
No. Give them 64, and the Intel will dictate how big the machine can be. or give them 32 and say, that's reasonable. In fact, honestly, you could get away with 24 and say that's
Right.
totally reasonable for the 99.999% of the population. And a handful of people need long strings, like capital long strings that are string like API, but infinite length. And then you'll blow out.
But isn't I mean, if you let Intel dictate how long the strings can be, then it's 48 bits, right? Because
yeah,
you
until
can't
Intel
press
changes the number of bits in
more memory
address
anyway.
bus. And then it'll be the size of memory, is what I'm saying. So don't go to 30, stick with 32 because it's way easier and won't touch so much the population. Everyone will work on it except people who know they have a problem.
Oh, okay, that's a good point. Yeah, the only thing I wanted to show is that I'm first what I did was saying, okay, I write 28 bits of hash, but I actually just read 32 bits, like the upper 32. But in most cases, that still means the lower 4 bits of the hash are 0 because the length will probably never get that big. And the second idea then I had to slightly improve the hash code again was to say, okay, let's not take the upper, like the 4 bits next to the hash code, but let's take the lower 4 bits of the length, which is not perfect, but a bit better than 0.
When you start looking at changing the hash code from the Java, which is everyone is widely acknowledged as a bad hash code, then there is plenty of research on better hash codes. Go stare at a better hash code and
go ahead.
Follow the research.
Yeah, I would suggest before you're trying to play with size, just look for a better hash function.
Yeah, I think I'm pretty happy. Let me with the hash.
Well, as soon as you're happy with your hash code, then the the more or less bits don't matter unless people just saturate your hash table. Like 2 to the 28th is whatever 1 billion or 500 million entries, but I can make a hash table with more than 500 million entries of strings, and then I will definitely start getting large counts of dupes. Okay, so you have some discussion about hash you're looking at, which is fine. I mean, I don't need to see it, but you need to have a good hash function. And then after that, I claim 28 bits will saturate sooner than 32.
Yeah, of course. I'm just, I think it was just interesting bit where I spent way too much time on. So yeah, let's see how it works out.
Yeah. Back in the day, Java started, no one made these giant things because no one did. And then I went to Azul and we had big single memory boxes, and we quickly ran into clients who ran more than 500 million strings into a table. And the hash code's all saturated and ran out of bits and endless collisions.
Yeah, I guess it's more likely to have like 2
billion strings as opposed to a string of 2 billion length.
That is like a billion bytes.
Yeah,
let's see. I haven't benchmarked it at all. I would be really interested whether the additional shifts are measurable when
that's not your cost. As soon as you get to a better hash function, the Java function is extremely cheap to compute. There are vaguely really difficult fancy shit you can do to get cheaper ones to compute, things that do like vector math to compute a cheaper hash. The Java hash is
I mean not cheaper at computing the hash itself, but cheaper at extracting the hash. I wonder whether like retrieving the hash code has a measurable difference between like using 32 bits and just getting them out and using whatever kind of magic and having to do some bit shift.
Because what you next do with that hash function is you mod it to the hash table length and do some lookup math with shift and adds on the arrays and the like. x86 eats shifts and adds like nobody's business.
Yeah.
I claim that's cheap. You want a better function, so you have fewer probes in the table, that's expensive. And then you want being able to extract without the shifts just makes people's understanding what the hell's going on a lot easier. And then the array range math that also must follow gets cheaper if you can leave yourself at 32.
Yeah.
What was the advantage of not just using 64 bits? That's the register size on most machines.
The only
Sorry?
thing with 64 bits is that it inflates the size of every object and turns into a effective reduction in your cache size, which does go straight to performance. Having said that, I would say don't put a hash on every object. Do put a hash on strings. And then I'd have to ponder 32 versus 64-bit string hashes. Strings might be one of the guys who you'd like to have a 64-bit hash. There are very few guys that you make billions of and throw them in the single table. And generally you know it, but strings are a common user object that people in fact do make billions of and don't envision.
Yeah, maybe I should use like 30 bits for the hash and
I would claim get it out of your
24
header
bits for the length.
and put it in a separate field, and it's, you know, you got a
Yeah,
length.
I mean it only lives in the header due to some technical restrictions.
Yeah, I would claim get the hash out of the header. I did that for Java, of course, and then like never again. Get the hash out of the header. 99% of all objects don't need the hash, and those header bits are scarce, and everyone has to have them.
No, it's really it's not part of the header. It's really just for this specific string type.
Oh,
There
okay.
is-
I'm sorry. Yeah, when I say header, I mean the thing that's for everybody. If you're looking at a string
Yeah.
type, then split the length code from the hash and have the hash just be a standard, U64 and walk away. Come back and revisit that and say, I want 32-bit hashes later if you decide.
It's probably premature optimization, but
I
yeah,
think
it
premature
was. I
optimization
mean,
is arguing 28 versus 30. That's premature optimization.
yeah.
Get the language going, people loving it, but and along the same lines, I'd say the easiest possible thing to make it, I get it to go, is to pick actually 32 and walk away
That's
from
true. Yeah. At that point, I was so frustrated with alignment issues that I said, okay, I'm not changing the number of bytes. I'm just trying to stuff as much bits as possible into the length field.
Yeah.
Yeah. The only thing I'm wondering is currently when I'm creating a string, I'm first doing a mem copy and then going over the bytes again and computing the hash code and where is it? It's here. And I'm really wondering if it's sorry.
Well, you go ahead. You finish.
I'm really wondering whether it would be smarter to try rolling the whole copy and hash operation into one loop instead of having two. But
yeah, okay. So we all love premature optimization. Yes. So this is another premature optimization. So in my head, that these things go like the number one most expensive thing you do with a string is create it because you copied it. And that is the most expensive thing. Everything else is chump change compared to blowing your cache out as you copy the string bytes. Okay, having said that, if it's a small string, the second pass is all hot in your cache and it's not so expensive. Not as expensive as the first one, but it's easy to roll together. The next one is, rolling down our premature optimizations in the cherry picking game is to agree that you'll never have a zero hash, and a zero in the hash table means that you're going to create it lazily. A lot of strings just showed up because somebody says, quote, log file colon plus quote the name plus quote blah 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 blah, and those never get hashed. Yes, and anything you touch with the hash is a total waste of time there.
I'm the only the main reason why I don't compute a hash lazily is basically that I really want to have stuff immutable, even in the implementation. It always feels a bit icky if
I-
you say,
I'm-
okay, let's pretend this string class is immutable, but underneath you're doing interesting stuff.
In the land of immutability, I am totally willing to go to the place of one-shot transitions to the same value. It starts some value and all threads can simultaneously one-shot it without an atomic operation into some other value. And that would be 0 to non-zero for a hash, or not a knitted to a knitted, or whatever that's going to be, because it's very, very close to immutable. It just delays computation, and maybe it delays it indefinitely if no one ever looks at the hash.
Yeah. Yeah.
And because you go to the same value, you don't have to.
Yeah.
do it. And
I mean, the best
So-
performance optimization is not doing work faster, but avoiding doing the
Yeah, it's
work
avoiding
in the
work.
first
Right.
place.
It would be some kind of effectively immutable because the calculation will always yield the same result.
Yeah, so at least, I mean, we wouldn't have to worry about race conditions if multiple threads access it.
that's
But
what I'm saying. It does this thing. Yeah.
It's just a little
So
slow machine.
the main cost in all these games is allocating by copy. And if you're planning on immutability, why aren't your strings just pointers to immutable, character arrays with length and offset? I mean, I have
just,
arguments the other way on that as well, but have you thought about?
You mean just having one big string and then only
No.
dealing with offsets,
No.
or
How did somebody make their string in the first place? They started with a pile of characters. I don't care where it came from, and they said, make a string out of it. Okay, if those pile of characters are themselves immutable, you don't have to copy that pile of characters.
Yeah, that's an interesting point.
Now, having said that, the obvious fail for that is somebody says, I have this XML document that's 2 gigs that I sucked in. I want to make a string out of this little part in the middle I found and none of the rest. And if you just do length and offset, and that's the only string, then you eat 2 gigs for a 10-byte thing you found.
Yeah. I mean, Java changed that a few years ago, such that substring actually copies the string and doesn't keep larger
There was
value.
screaming in both directions. Reasonable screaming in both directions.
Yeah, I mean, if people had used the jar sequence interface, maybe we could just have 2 different strings and everybody would have been happy.
Yeah,
but
it gets complicated. So I do like language parsing all the time, and all the identifiers show up in the byte array in the giant program text. And I end up keeping all these strings for all those cars floating around, but I end up with lots and lots of strings in the same car array. So I am totally willing to do base plus offset in program text parsing or XML parsing, because you typically end up with a bazillion strings, ratio of strings proportional to the size of the thing you're parsing. So it goes both ways. It's just that's the thing to think about.
Yeah.
And I see break and continue.
Yeah,
You don't
I'm
like even one level breaks or one level continues? I saw your comment. You want to change topics? Are we done with death by strings? I'm interested in break and continue. Multi-level break and continue I find obnoxious. One level break and continue I use daily. So I want to know what you're thinking there is.
Isn't the multi-level break just another word for go to?
Multi-level continue is multi-level breaks. Not really. I guess it is. Yeah, I guess so. Yeah, right. Yeah, it's a more structured go-to, but yeah, it's a go-to.
Isn't the problem with continue the fact that if you don't put it in, there's this weird thing where you drop down into the next block and it's not obvious unless you are schooled in the art?
I'm not sure what you mean by you drop down. Continue is shortcut.
I guess we're talking about case statements or loops.
Yeah, the obvious choice is I have a bunch of nested if then else's, and I'm nesting as I go a bunch of tests of whatever kind, and then I do my work, and I'm in a loop. So, and if I continue, then I don't have to keep nesting. I test, I fail, I continue, I test, I continue. I'm not getting the death by indentation that JavaScript hits, because I don't keep sliding my body to the right every time I have an if test. Like you do an if test to do something, Then you have to do some actual work to extract the next thing out. The if says it was okay to do the next step, and then you do another if test, and then you extract another if test. So it's not like you can say if and if and if and if and. You have to do if some stuff, and it keeps with a fucking pyramid of doom or something. There's a word for this, and continue to avoid that in loops. Now, having said that, multi-level continue, I'm totally is like with you. It's like a fucking go-to. And actually, if I was going to have that, I would choose a go-to instead, because everyone's eyeballs should alert go to, red flag, what the hell, and then not get confused by a labeled continue or labeled break, which is just a go-to under another name. And then single level breaks you can get rid of if you take your code and move it into a function and do an early exit return. Having said that, I do early exit breaks all the time, and I kind of like, if it gets a little more complicated, I move it to a function and do an early return instead. That's okay. That's my thing. Now, why are you claiming we should get rid of all breaks or all continues? Let's go with continues first. Breaks have
That's
show
I
me
can do
an
window
example
management
where
magic.
Continue or some argument why continue.
All right.
Oh, I don't
So
like
basically,
continue equals false. That's a keyword thing, but never mind. That's you using a word there. I mean, never mind. I see. Let continue equals true, and then down below continue equals false, and while continue. Yeah, I don't like the Boolean flags. I do them all the time. I don't like how they work out. I'd rather do a break, which in turn turns into, at some point, I turn it into a function with an early exit.
yeah, the basic reasoning is that you have like 3% of your code, or probably even less. You have
Not my
code.
code.
Sorry?
Never mind. I'm hassling you. I'm giving you shit.
Yeah, sure. Yeah, you have a certain amount of percentage where like a break or continue would really benefit reading the code. And then you have like 97 or 98 or 99% of the code where you are not using break and continue, but every time you read the source code, every time you read a loop, you have to be mentally prepared. Okay, that could be a break or continue somewhere in this loop that does funny things. And I'm not claiming that I'm not making the 3% worse, but I'm making the 97% of the code that doesn't use break and continue slightly more convenient, because people simply have too fewer things in their heads they have to keep remembering. And yeah,
I don't
Okay.
know. Wouldn't it be the same thing for like early returns? I mean, there's this whole discussion. Do you do that? Do you don't? I
Oh,
like
gosh,
early
no.
returns.
I'll fight
I
to the
don't-
death for early returns.
Yep.
Oh, me too. I mean, I don't want to read any further if I don't have to.
Yeah.
So on the break situation, I just did the stupid straw man 10-second pull by looking at my source code. And two of my very larger files have respectively 2 breaks. These are thousands of lines of code files, have 2 breaks and 5 breaks out of thousands of lines. So I have moved most of them to early returns.
Oh, it's less than 1%. Yeah.
Yeah,
So,
yeah, it's low.
in return, of course, Chris is right that you can more or less make the same argument for return, but in the end, I mean, it's a necessary evil I can live with, because in a sense you say, okay, this is a return, you're basically leaving this method anyway, so don't worry about any other parts. I mean, it's fine. If I could, I would of course get rid of it and force people to write code where every thing is an expression and there are no statements, but maybe not ready for this yet.
To be, you know, in the realm of famous language designers and the amount of hate they get from the users. Not to mention Strawstrup or anything.
Yeah, I mean, in the end,
although it doesn't seem that different to what AA decided to do.
Exactly.
If you're doing a for loop, just put a func in the middle and return from that thing.
I'm in the zone of it's early returns. And the body of a for loop is its own lambda. It's a block like you get out of Self or a bunch of languages. It's a code block. It's a lambda function, and you do an early return. That's your break statement.
So if you return from a lambda in AA, do you return into the, like, you just return out of the lambda, not out of the whole function where it was defined in, I guess?
Okay, there's no difference between functions and lambdas. They're all the same thing. I make no distinction.
Right. Does that not get confusing because you've got a function body and there's returns, but you have to recognize, well, actually, this is a return out of a lambda. I think JavaScript does this.
I don't have lambdas any more than I have functions, or I have functions slash lambdas. So when you say lambda, say function or lambda or function slash lambda, because you mean both, or I mean both at the same time.
Yeah.
So that there's no distinction between them, and my return exits you, the one layer, the one function you're in. But people write nested functions, and that's okay, and you don't get to have a multi-layer nested exit because that requires one function be aware of some unrelated function.
Yeah.
In order to do a multi, I have no clue what a multi-exit would mean in that context. So now I should shut up now.
We call that broke, don't we?
Yeah. Broke, not break, but broke. I can show examples, but they're just going to turn into what you would expect out, a little different syntax than what you expect out of an early exit. And including out of a for loop that's inside some other function, but the body of the for loop is its own function, and the one exit out of it just effectively breaks out of a for loop. That's the only deal. Like my for is itself not any special syntax right now. It's just another user function that's a functor. It just, or not a functor, whatever. It just takes two functions and executes one for side effects and executes the other for an exit condition until they're done. But you can exit out of either one, and that exits the for loop like an early exit. I guess I'm more interested in the continue game, which I don't know what to do with. Oh, I roll continue into my early exits as well, actually, in AA. Yeah, you're using variables for the name continue. I want the Java continue. Let me go look for continues in my code here, now having done the...
Yeah, I mean, the benefit of removing break and continue as keywords is that you then can subsequently use them as variable names. So, of course,
no, I'm looking
that's going to happen. So
yeah, I know. That's just a quick. That's okay. I got a lot more continues. Not a huge count though. Let me look at some other...
I mean, continues basically force you to say, okay, everything above is an if, and everything below is an else branch, which is another level of nesting. But yeah,
I would actually agree. I'm pretty sure that most of my code has a lot more continues, because what I mostly do is, as you said, you have a lot of preconditions. You check them, and then they're not met. You're just doing a continue, like
that's exactly how I use it. But now having said that, go run a greph on your source base. This is not a hard problem to go get some numbers on.
In the end, if I'm looking at the language I'm working with, in the beginning we had like 6 control flow constructs, and now we only have 3, and at least in my book that's an improvement, because I mean, 6 control flow constructs, I think that's a bit too much.
That's a lot.
Do you have both for and wow?
Oh, true. That's then we have even more. So
all right,
I have it. So basically we have like endless loop as control flow, panic, and exception as things that simply like abort or like never return anything. Endless loop I will probably not get rid of.
Why? You say while
panic.
true.
Sorry?
Why do you have endless loop versus while true?
I know. I mean that's basically while true. Yeah, I will probably not be able to get rid of endless loops. Panics are also here to stay for things like indexing with the wrong size, like index out of bounds. I mean, you can always do it more safely, return options everywhere, but somewhere underneath, you still want to be able to say, okay, I'm really, really sure, panic if I'm wrong. Exceptions are gone, break and continue are gone. So basically we have return, panic, and then loops if you
So
want
if I
to.
understand correct, panic does not work as in Go, right? It is not like your normal error handling weird kind of thing. I mean,
No, panic
Go
means
is weird anyways, but
no, at least in this implementation, panic means sprint the stack trace and terminate the program. So there is no way to recover.
okay, yeah. Well, that was the original idea in Go as well. And then they thought, well, maybe you really want to recover from that.
So in all these things, the next step after panic is that panic goes to the debugger. So the runtime gets all the support to recover and let the debugger take over, who wants to undo the array index out of bounds exception and let the user hand edit the index and then carry on.
Yeah. Or panic goes to the supervisor and
Right. So
gets
panic goes to
restarted
the-
at
right.
exactly the next line or something.
Goes to the next level of defense who somebody takes care of it, which means it's catchable in practice, even if in theory, in the language theory, you don't want it to be catchable. In practice, it's catchable and recoverable because that's how debuggers work. And now you have the problem that there is no exit that just ends everything. Every possible thing you do is going to be catchable by the debugger. And therefore, it's catchable by your runtime, and therefore your runtime can totally handle every possible exception and panic you throw.
Oh well, then let's simply not support debuggers.
Sounds like quiet quitting.
Yeah, obfuscating the code generation until GDB gives up or something.
Well, then people will hate you because you can't debug your code.
Yeah, that's
No,
yeah,
nobody.
no.
I'm claiming that you shouldn't
You
have.
don't need a why do you need a debugger? Just write correct code.
Exactly. Exactly.
Like if it compiles, it's correct, right? That's why we have types.
Did any of you guys see the Carmack talk that he did recently, where he talked about doing all of his development with the debugger running? So he never doesn't have the debugger running, and whenever he's developing, I don't remember the details because I don't do that type of code, but I don't do C++. But yeah, it was interesting actually.
One of the grand wins for Azul was that we allow the debugger to be attached to a JVM that was running in production. And fully attached with all kinds of cool profiling shit brought out and all kinds of, you could look at the generated machine code and everything else, plus a bunch of mapping stuff to help the debugger figure out what the hell's going on. And what it meant was, and the overheads for doing that were actually really modest because of the way Java does, code generation on the fly. And what it meant was that as soon as people figured that out, it was like, oh my God, yes, you go to a running JVM, it's not crashed, but it's running really slow. And the server is like lost all performance. And what the hell is the server doing? You could hook a debugger to it and stare at code bits, and you could stare at data bits, and you stare at
Clear some hash maps in real time.
I'm sorry?
Clear some hash maps in real time.
Yeah, you could clear hash maps in real time. Yeah. They're all
calculate them yourself. You can recalculate your own hash maps.
Well, you had to change the hash function or something. I don't know, but people would do stupid things, and then they would be confused because it wouldn't show up in testing because they didn't do any loads. They could get it under load, and they could see where it failed under load. Fine. All right. Well, you want to? I'm going to agree with your numbers for break and continue. I just did the AA code base grep, and out of however many 100,000 lines I have in AA, I probably don't have that many. I probably have 10, 20. I probably have 50,000 lines. So I got 81 breaks and 93 continues. And I know that I can deal with the breaks with generally a step out function and an early return. So very small count of breaks and continues.
Yeah, I'd expect that the painful breaks and continues where you really have to look
Matt, did
deeply
you put
into what
that
the
link in the?
code actually does is like 10% of all breaks or something. Most breaks, I guess, are trivial.
Yeah, yeah. Matt, did you put that link? Because I do a lot of things that sounds like what I do a lot of things. I get close and then I use the debugger to figure out what's going on.
Well, if you read the rest of the paper, so it's on tree width. And so like the tree width is kind of this measure of complexity of the program. And what they say basically is that the breaker continue it increases the tree width by 1. And so it doesn't actually make it very complicated. The labeled breaks and continues do have the potential to make it unbounded, but like in practice, it never went above 6. So, I mean,
Yeah.
so in practice, most programs aren't that complicated, but you know. I mean,
I claim those measures of complexity are sort of bogus, but fine. Like you run that on like the hotspot source base, and it'd probably tell you it has a certain complexity, but it totally skips all the things that are subtly correct because of race conditions that you've carefully handled in all ways or not, and it has no way to measure that or know about it, or to know that the handshake between the generated code, invariance and the runtimes invariance, and so they can't measure that kind of complexity. Like the code itself has a complexity, but the actual implementation of what it does can get way more subtle, way more quickly. Anything else you want to talk about, Simon?
Yes, I have one short one. I implemented total order comparisons.
What's a total order mean?
It means that for instance, if you're comparing -0 to +0, it will say that the one with the minus in front is smaller.
Okay.
And it sorts not a number in a way that's stable. So if you're doing sorting, or if you have like a tree set or something, all the lookup operations just work. And,
okay. So 2 nans are not equal, they're ordered. 2 different nans.
Yeah,
like the usual rule on Java for nans is if you ask a question, is this nan equal to that nan? And the answer is no, including if it's the same nan on itself, which kind of sucks.
Yeah.
For generating compiler optimizations, because usually you can do something with equals. If I say
you're not going to be able to distinguish between different nans if you're using a native floating point implementation.
Yeah. But has anyone ever seen this? I mean, I think for
the
ARM,
weird NAND games.
Yeah, I mean, ARM explicitly has a CPU setting that says basically this is our canonical, not a number. Never give me anything else, and I think it's on by default. And
yeah, the IEEE spec says one thing, and then people implement another. But the 99% coding solution is that you only need one NAND.
Yeah.
I don't know, back in the 70s and 80s when this was being argued out, there was reasons to have multiple nans so you could track various failures from various places in the code.
Yep.
Large, complicated Fortran loops would do something, physics simulations of some kind, and you'd divide by 0.
There are reasons to have multiple nans, but having 2 to the 54 nans is about 2 to the 54.
Maybe more than necessary.
Yeah.
Certainly in AA, we take a, matrix multiply of billions and billions and trillions, and something failed across the clustered, and you got back a NAN, and you're like, okay, now where's the bug, right? What happened? The numerical instability somewhere. You have to go try and sort that out. There might have been a case for varying kinds of NANs. We voted against it. Said we'll just go live with one NAN, make life easier.
Yeah, one thing
That
that's
is
really
an interesting idea, to have every line of code where a NAN could possibly be generated numbered, and then give numbered nans that tell you what line of code generated.
Okay, so you do some math for a while on your numbered nans, by accident, of course, and you have to merge them. So you add NAND flavored left and NAND flavored right. What do you get?
The first one.
Why not just make NAND like a special object like string is and give it a hash code?
I'm working on this one here already, because immediately what it says is the first one from the language semantics. Of course, by the time it gets down through the JIT's busy folding all your arithmetic and swapping things and register allocating and shit like that. You have to guarantee that I get the left argument NAND out of an add instruction. I guess it's doable. It's definitely right hard into the code generation.
I think what you'd maybe on that theory, if you've got different NAND possibly generated from every line of code, then if you do, you have to have an add of floating points also be a possible numbered NAND.
Yeah, of course.
So it's not the left or the right. It's a new one.
It's its own. Yes. So as soon as you do that, you lose. Right. So there is if I add two NANDs, do I report the add location as a new NAND, or I have the left NAND or the right NAND? And if you report that add, then you lost where the original NAND came from. And that's the key thing you need.
Always report the first one that occurs, and then it can go and fix things successively.
Right. If you report the last one, you can't ever find out where it came from. That was what usually happened to us. We get a NAND back in the end, and then we're like, oh, where did this NAND come from? And so you start putting if tests for NANDs, and after a while, you find where it came from. And it came from a prior NAND. Oh, and you put more if tests in, and there's no debugging that routes you back. You have to, like, one at a time, you roll backward the failing cases and reran the giant billions calculation until you finally sorted the original NAND.
Or do you just swap your primitive math operations temporarily out for ones that blow up when they NAND?
That is
the
not
idea of tell the runtime to switch to NAND tracking,
and NAND causes immediate fault. Lower. So we thought about that. We screwed around. There's a funny issue there that as soon as you think that way, you'll write code where it's okay to compute a NAND for a while, and then you'll get rid of it, and then your NAND tracking doesn't help anymore. Your NAND checking, because you're checking NANDs, or you're exploding NANDs by default all the time anyhow, and then getting rid of them.
What I was saying is you actually have mode, and so you switch between modes. Maybe you do that in per block or something. I don't know. Just sort of think.
I didn't have any way to do that in Java per se. Like the JVM itself comes up and immediately sets these modes. And then the way you flip it is you can go into JNI code and flip the mode. But what you don't know is secretly under the hood, the JVM emits code for doing the round off fix up error for like sines and cosines and tan, whatever crap, where he'll generate a NAND in between and then decide he doesn't need it, throw it away and carry on. But if you're faulting, then a standard sign, which isn't going to produce a NAND except internally, now faults, right? And that happens because it's processor wide. That happens for everybody else on the same processor. So if I call BLAS while I'm doing my big data math calculation, and the BLAS library likes to torture NANDs and shit, I don't know. Some of these libs got good about it, and they would set and reset the NAND is faulting and then restore it. Some of them were bad in that they would just wipe it to what they wanted, and then your use of NAND faulting got wiped out because you called this other library routine, right? I don't know what the situation is now, but having a processor-wide thing that's effectively not managed by the kernel means that everybody on the planet has to be a good neighbor, and they're not.
Welcome to ARM.
Hey, maybe we're all good neighbors now. I don't know. So I wouldn't worry about this yet.
Yeah, ARM has a processor-specific register with a bit to say, okay, I only care about a canonical NAND or different NANDs. And
it's a reasonable thing to do, yeah.
The sad thing is that Intel and ARM, of course, disagree what's the canonical NAND. So if you divide 0 by 0, you get a different NAND on ARM than you get on Intel. The Intel one is negative, and on ARM it's positive.
Wow.
Like I have
Yeah,
found
I
it.
always thought the canonical name was all ones.
Yeah, I found out the hard way when I wrote the test, and I could make the test run either on ARM or on Intel, not on both.
That's interesting. I did not know that.
Yeah.
That's one of those things that a JVM can in fact hide from you by
Yeah.
doing different code generation under the hood, but yuck.
Yeah, I mean that's what there was one insight, that different CPUs use different canonical nans, and the other thing is that something I did earlier. I have here intrinsic for my float comparison, and I only wrote intrinsic for x86, but not for ARM. And a while ago, I implemented some kind of mechanism for optional intrinsics. And I can only recommend it. It's really convenient being able to say, okay, I have here the implementation in high-level code, but I can also say, okay, internal, if you find an intrinsic that fits that function, use the intrinsic. I mean, a hotspot has roughly the same with the hotspot intrinsic candidate thing. So I was really happy. It's really helpful. You can prototype things, try things out architecturally, and you are not forced to implement the low-level stuff on every platform at the same time. So that was a nice takeaway.
How do you test if that intrinsic has the same behavior as the internal implementation version?
I edited it out.
To trusted computing base.
Yeah, I mean, if I have time, I will probably implement a switch where I can say, okay, toggle off all optional intrinsics, but at the moment I just remove the internal and add it again later. But it's, I mean, it's easy enough to figure out that it has to be equivalent. So, yeah.
I mean,
Sorry.
I said that's a little manual, but it's effective.
Yeah, I mean, implementing the toggle would have cost me some hours. Editing it by hand costs me seconds. At least if I want to run it both ways on the CI, that's of course not manageable. But at the moment, everything is small and easy and not too many different failure
There's definitely
modes.
something to be said for convenience in exploring the architectural design space. Huh.
Yeah, that's basically the end of my, I have implemented this list.
Yeah.
And one thing I've been thinking about some while ago is like the last point of saying, basically we want to have some kind of code gen or macros or type providers or compiler plugins, something that allows us easy access to type definitions that are not internal to our language, but definitions that come from somewhere else. And in the past, if you look at the history of computing, I'd say we had many different approaches and they all had various problems. I mean, the whole compiler plugin approach is basically the plugin API is never powerful enough to do useful things on the one side, and the other side, the compiler plugin API is always too large to to evolve the compiler in a meaningful way without having to break the compiler plugin API every 2 years
stop
or
sharing
something.
here and go back to full screen people mode.
That's
interesting.
a good
Compiler
idea.
plugin APIs.
And I mean, F# tried something like with type providers, where you had like special codes that also hooked into the compiler, where people could implement these kinds of type providers and had direct access to like databases and could auto complete into the database and so on. And that's yeah, I mean, of course we have like the code gen way of just generated source code. And did you want to share?
No, I was just going, we were staring at your screen, was unmoving and unchanging, and we were talking about it, so I thought I'd just switch to.
Oh, right. It's in the Google
You want to share
Docs.
again here? You
If
got
you want,
something
no,
to share?
if you want to share, I mean, it doesn't matter who shares. But
I'm
Do the
sorry.
fourth thing where the interpreter is small and your compiler is the fourth code you wrote, and the compiler API is the fourth code you wrote.
Yeah, fourth could do it,
let's
but
try
like,
it.
like we tried at Hotspot for the garbage collector. In the end, there were probably a dozen garbage collectors, and the garbage collection API changed rapidly and repeatedly as people kept adding new core things and trying to do it. And it was extremely difficult to maintain any kind of compatibility, and there hadn't any thought going into it in the first place, and it had direct impact on code generation as well as runtime things. So it was a non-trivial task to go change the garbage collector API, but the new GC on the planet wanted to have something different in his, you know, whatever he was handling, read barriers at all versus differently. He's handling thread locals versus whatever. The whole garbage collection API thing was a giant, you know, flustercluck before it settled out in something kind of sort of reasonably stable and hugely complicated. And the compiler API was like without bounds. Like it's all good to say I have some byte codes and I'll generate and hand you back a wad of code, but there's lifetime management on that wad of code, and the lifetime management, the compiler had to tell the runtime under what conditions the code would stay or go, and then the runtime had what conditions he was going to do to wipe it out. And there was profiling data that had to come and go, and the profiling data had itself deep complexities because you had inline profile counts of things that code that would disappear out from under or whatever. So I don't know. This is a hard problem to make simple and have it be useful without sort of butchering your performance or you know, making it impossible to make forward progress. So these are ugly issues for sure.
Yeah. So my idea was to say, okay, let's try a different approach instead of trying all the ways that we already tried and not being successful. Let's try something else. And the basic approach is to say, okay, the file ending of my language, of my compiler, of the file ending of source files that my compiler accepts is like .core. But what if the compiler would also accept files that had the ending XSD, for instance, and then say, okay, an XML schema definition is a valid syntax or a valid language of my runtime, of my compiler, and then say, okay, I'm stealing an XML parser from somewhere. I'm reading in the XSD file. I'm generating the same AST that my other input language would generate. And after that step, it's basically not distinguishable anymore whether I define my class like this or whether I define my class like this.
This is exactly a front end for a language. It doesn't matter how you input. It's how it matters is you end up with the same AST trees. So it's a front end for the language.
Yeah.
Okay, so the semantics of the XSD and your language have to be identical then as well. The semantics for data structure definitions have to match, or you can write an XSD that you can't express in your language, or you can do things in your language you can't do in the XSD.
Yeah, exactly. I'd say that the things you can do in a language are, of course, a superset from the things you can do in this language. For instance, in this language, you can't define functions, but I mean, it's close enough if I get an XSD file from somewhere and I don't have to do any other steps to work with XML data, I'm not complaining that I have to put my function definition somewhere else.
So you're what you're doing is basically taking the, well, whatever you want to call it, entity approach that a lot of game engines and stuff do, where you basically can create your objects as, well, as declarative way, and the front ends or UI in a declarative way. But as you said, it means you can basically only do like record classes or something like that.
Yeah.
But I will warn you, this would put much strain on the type of the trees you have. For example, if you compare it to Scala, the Scala has such a generic interfaces like a tree is something that it can be nailed down to a val, to a def, but it's a tree. So in order to not restrict the AST to give it more flexibility, it will, at least to my opinion, it will go there in order to support the wide range of pointers on how you generated the AST. I can be wrong, of course.
You mean whether some things are mutable or immutable fields?
Let's say for a value, for a val or a class, something that has pretty defined semantics, it's too left as a tree in Scala, for example, in order to accept the widest possible trees.
I'm not understanding the tree. What's like
a tree in Scala, for example, the top of the AST is a tree. Yeah. So if you have you have an AST for a definition for a function, yes, the function itself accepts or a term or a return type or something else in order to describe the definition of a function inside the Scala language. I'm talking about the AST.
Mm-hmm.
And if for Scala it's a def, for example, the def accepts a term, accepts a return types. Yeah, they're intentionally left some kinds of AST that accepts a tree, not a specific subtree, in order to maintain its flexibility in the AST. That puts much more flexibility on the AST, but you have then to be careful in order to pass something that's not that it doesn't belong there. I'm not sure that would go there, but I think it's a possibility.
Okay, I'm not sure if I understand correctly, but I mean, in both cases, regard whether you're doing this syntax or this syntax, the AST that falls out should be identical, at least for this use case. So I mean, sure, you have to write the front end that reads XSD and builds the AST, but if you assume that the front end does things correctly, you shouldn't have to deal with unexpected trees coming from here more than you would have to deal with them from coming.
This is an answer too. That means no matter how the front end language goes, it has to conform to what you consider a class definition.
Yeah, I mean, I'm not expecting that that everybody and their dog is now writing new front ends separate from the compiler, but yeah, I'd expect like if there's a front end, then it should be in the compiler source code so that it benefits from all changes and improvements to other parts of the compiler. And the reason I'm not worried about is that of course you have like an endless amount of possible input languages, but that amount is, I mean, it's a smaller infinity than saying, okay, we're doing like codegen with Java CC for every random XSD file we find out there. I mean, if you add compiler support for XML or XSDs, some kind of JSON schema description, maybe some binary input formats like protobuf property files, and maybe some kind of database connection strings, you've dealt with like 80% of the important things out there. And
it's intriguing to make your language the widest accepted formats possible, but at least my opinion, that have to have come to a later stage. You have to focus on your language semantics first, what you consider to be your language, what you cases you want to support, and then you want to try to generalize your representation in order to fit more languages in it, because at this stage your language has not specifically carved its semantics, its meaning about your language. That is my opinion, of course. But it's certainly a possibility for anyone. Try to accept an XML, a protobuf definitions, a C definitions. In order you
other languages, then it gets
I'm
ugly.
interested. I mean, it sounds like a reasonable way to get cross-language compatibility rolling. Just you know, in the beginning, you always interoperate with everybody else because you know you
need
one
to
user yourself, or you're trying to get a second or a third, and they're trying to do something interesting, and so they have an existing project they're working on and problem, and there's an interop problem. I think, you know, or it's always only ever greenfield, or you got an interop problem. Okay, you got an interop problem, then what do you do? So JNI, foreign function interfaces. This is another.
Yeah, I mean, support everything, but don't make it too convenient.
Well, and protobufs are exactly out there because there's an interop problem on the data.
Yeah, I mean, I had Gen I in mind.
So, you know, every Java doc library, not Java doc, every Java JSON library in Java is all about reading a JSON spec and producing a Java object that you can screw with, right?
Yeah.
I think this is an entirely reasonable thing, other than, you know, people who do XML should be shot, but that's a different story.
Yeah.
I'm not the XML fan, fine, whatever. But the same can be done with JSON, and I like your database thing, so that's like a reasonable database.
Yeah,
and everything else.
But I would argue that JSON is definitely the front end language to interface with some kind of backend language.
It's like having protobuf as your front end. No, it's a very specific piece. It's just defining a data structure, you know, giving you a data structure description. But JSON, now I want to work on those objects in my language directly. Why do I have description language here? I'm getting probably some serialized, deserialized thing from somewhere else, and I'm going to move them into the semantic equivalent in my language. Then I can now dork with, you know, Persians, whatever that means.
But we do need language independent serializations to move stuff between different environments.
Yeah.
I mean, I think our web APIs would be more confusing if they were all like CSVs.
But at the same point, Simon can make its language a serializer, deserializer from any source code to its data structure and treat it as a serializer, deserializer, in order to provide a specific.
It's not a language feature like I see what you're saying. Maybe I see what you're saying. Like, instead of doing this where you eat the XSD in the compiler, you instead say, I have a library which understands XSD sources, and I'm just going to use my library, like a JSON library, JSON or whatever, is exactly solving this problem.
And the endpoint is
compiler.
And the endpoint is AST generated for the compiler to consume.
Yeah, you want a type safe output, which in JSON or JSON, it runs through the class for name. You basically built a
no,
class filey thing and then
it's a matter of
yourself.
preference. Do you want it to be with a compiler plugin, or do you want it to be a library? It's a
Yeah, my
it's a-
theory is I'm going to do eval, and you're going to parse an XSD. You're going to produce an AA string called eval, same as class for name, and you're going to get a strongly typed thing in the language I can screw with directly.
yeah, that's
Do I
that's
put
it.
that on a compiler command line? Only if there's a convenience use for it, but then it's not hard, as you said. I'm just going to grab an XML parsing library, and it's only partial program. So all you get out of this is description, which you generate a .o out of that description, data structure description. Well, that's your entire compilation unit, or it's part of a compilation unit, and the rest of the parts has to show up. That's why you put it in line, maybe. I don't know.
People certainly do stuff like that for protobuf.
I have the entire compilation unit. Is that Aaron?
Yeah, I've seen protobuf stuff that you just get a .o that is, here's all the protobufs that we compiled.
Yeah, okay.
They're kind of slow and you don't want to recompile all the time, particularly if you're doing a lot of protobuf from Python.
Your audio is really poor, by the way, but I guess you try not to wake up the baby.
Yeah, I have headphones in that don't have very good mic on them.
I could not make
No,
that
it
out.
would be worse.
So don't worry about it.
So
Alright.
as for the Simon, at least to me, it sounds that it's certainly interesting idea, but you first have to work on the core idea of your language and then try to consume more formats for it.
Ah,
At least.
Yeah, I mean it's a fun project. So
It's your
it's
project.
like I mean just the project planning is basically deciding what I'm interested in today. So
Yeah.
that kind of differs from what would be smart, I guess.
Yeah. But speaking for Scala bad experiences, they try to take some literals and think they got nowhere with them.
I don't think
Hey,
they
Chris,
were
see
too
ya.
bad. I mean, blaming everything on the poor XML literals. I mean,
all right, let's roll on here. We've slowed down to a crawl.
yeah.
Yeah.
The only thing, so basically this is all the idea. The only thing I played with is doing support for properties, but because that's easier, I just say, okay, I have this key value thing, and I use the file name as a module name. I use the key here as a function name, and then I have a look at the value and check, okay, is there something to interpolate it, something to interpolate, and based on that, my function has another argument or it doesn't. And yeah, didn't make it work, but yeah, seems to be doable in a day or something.
Is
Right,
it
I
useful in a
think.
day? That's over just doing functions with like default arguments and stuff. Yeah, it's one of those features before. I want to say it's a premature feature optimization. Yeah, that's what Chris was saying.
Yeah, possibly. All right. Yeah, I think I'm through all that I wanted to show you.
I think Darrick
Aaron
can
asked,
share.
how do you do imports? In
Sorry?
the chat. Aaron's having audio issues, so he's asking, how do you import in chat?
I haven't really overhauled or implemented it yet, but it's
Okay, and you stopped sharing, and I didn't do that one.
So if you want to talk about my my only problem that I'm having with scheduling that I know of so far.
Okay.
Yeah, so maybe it's because of the way I implemented the compose select versus files.
That scheduling. Yeah.
Yeah.
Okay. Did you find the global code motion paper?
Oh yeah. I implemented that whole algo. I think I found one bug in the algo, but I'm not 100% sure.
Same algo been used for 25 years in Hotspot, so I think it's pretty stable. Yeah, it's the same algo. It's not quite fair. I did a bunch of expansions to it to go do smarter scheduling over what the algo does when you had hardware things you could do. But I
Yeah,
think the whole algorithm is pretty stable.
Maybe Darrick is just doing different things. So maybe you
Yeah.
haven't hit.
Yeah, I haven't seen
bug
the compose
personally.
select now. Maybe that messes around.
Yeah, so I actually took, this is your example from the combining and your PhD
Yeah.
thesis.
Yeah.
You recognize it. So in this example, you know, C is actually undefined outside the loop, and you can kind of pull it out of the loop like that and schedule it down
It's
here.
not undefined outside the loop. It's not used in the body of the loop, so it can be pulled out. I'm sorry, undefined means something special here. It's well defined.
Well, inside the loop it is, but if it gets its first assignment inside the loop.
And it gets over and over and over assigned.
Yeah,
values.
and then it gets reassigned multiple times. It's never used in the loop.
Yeah,
So yeah,
right.
but it's outside the loop. It's not defined, but then it's used outside the loop.
No, it is. Well, okay, I would claim it is defined outside the loop. It takes the last value of add as you exit the loop.
Yeah. But if you had 0 iterations on the loop, then you'd have an undefined.
If you had 0 iterations, you better have a 0 trip count test that goes around, and that would insert a merge point, which would give you that definition. So you have a minimum of 1. The loop it is written has a minimum of 1 iteration. It is a do while loop. It cannot.
So you would actually stick. You would generate the definition for that otherwise undefined C at the 0 iteration.
Yeah. Hang on. I wouldn't. I would say the program as written, mul is well defined in all situations. You cannot have 0 trips because the code is written that says I fall into the body of the loop. I'm doing at least 1 trip to the loop.
Right.
If you make a new program that is a different program that tests a condition and says, don't do the loop at all, I now have a different program. And that loop has in the hotspot source code, you'll see it as ZT something, 0 trip count, ZTC, 0 trip count test. And it just handles the case where I want to say I failed before I did the loop at all. In which case, things like mul get a definition that includes the merge of the 0 trip versus the body of the loop. And that's the mul is forced now outside the loop because it's taking a 0 trip result.
And
Oh
yeah. So I just realized that I've implemented this slightly wrong. So I'm going to have to make a change and see if I can see what it does. But what I was seeing right now is, so the semantics that I have, I couldn't express this because as I was saying, as I saw it, as I implemented it, the C was undefined outside the loop, so I got that wrong. But what that ended up generating is so what I ended up putting in is just an initialized C at the top, and so then on the return I end up with a phi, and so then I end up with this guy here.
Yeah. So something happened, and as soon as you took the broken semantics and you try to generate code on the broken semantics, you get a broken code, and then you went for a fix that sounded to me like the wrong one.
Maybe, yeah, probably. And so the thing that I'm not sure about is this seems to lock the multiply into the loop because.
Yeah, but you added half of an exit for 0 trip, but not the top half. The top half is if condition is false, don't execute the loop, or if condition, don't execute the body at all.
Yeah.
And that's so the select wouldn't go on that if, that's the loop trip if, it would go on the if that says skip the entire loop body.
Oh yeah, sorry. This should be pointing to the loop body.
Well, no.
I mean, that's what it's generating.
Yeah,
right.
But so,
that error wrong. And so I guess the first question is, that's how it structures for me. If I try to remove this restriction from the code motion, then everything goes in the wrong places.
Okay, so I claim, look at my version on the left, and what is or add and split the fee into two parts that compose in the select, and you only have one fee
Yeah,
because
Yeah,
there's
that's
only one value being merged on the back edge here.
yeah, because that's this one.
Is that actually how that loop went? I'd have to go look at that loop.
Yeah, I drew this exactly. I don't have I have the paper on my iPad.
No, that's fine. No, no, I'll believe you.
I can share that. I can share the iPad, I think.
Okay, and what I'm trying to say is the guy on the left is a semantically correct program graph. If I split fee into select and compose, it will remain a correct program graph. Scheduling with a split like that should work fine, although obviously select and compose should end up in the basically in the same basic blocks or right next to the right basic blocks, because they are pinned into the basic block header or basic block tail according to what you're doing with them. So the splitting the fee into select and compose shouldn't change things. Adding a new select and compose is is just incorrect here. Adding the new one for the mole, that's just incorrect.
Okay, so I see. So, but okay, so if you had a 0 trip count version, then
you get a whole new.
You'd still end up with a select and compose, right? It would just be a bit different structure.
You end up with multiple select composes like you've got there, but you also end up with multiple ifs that are merging. Yeah. And multiple regions that are merging and multiple ifs that are splitting, and that's the difference. That's what we're missing here. Here you've added selects and composes as if you had a 0 trip count, which you don't. But if you had a 0 trip count, you have an initial if between the start and the top region, and you have a late region to merge the trip around from the exiting loop if. So you'd add, a bracketing set of split and merge around the loop, and the select composes that go on the bottom region, which you don't have. So I would claim start with the guy on the left, split the fee into two parts and the select compose. Let's see what it looks like. Then write the one with the 0 trip count, see what it looks like, and you'll see that you'll have a place to put the mole on the 0 trip count version.
Okay. So a simpler question. Say that this is the code that I wanted to write.
This is not a correct graph. It has no program semantics that I can sort out. So I don't know what that program on the right means.
Okay. Or I guess what I'm trying to ask here is not so much about the program as a whole, but if you just look at this, multiply this select and this compose that's pulling the value that's being set inside the loop. Is it correct that the existence of that, or if you're doing it this way, that the existence of the fee pins this value that's being selected into the block where it's defined?
So the problem I have, the graph on the right, I just said it's not a correct graph. It has no semantics that mean anything to me. So I would claim trying to draw conclusions from a broken program is it's not a good plan. You start with garbage in, you get garbage out. Don't go there. Take the guy on the left, the mole's not pinned in. Add a 0 trip count, the mole's not pinned in.
Right.
I can even imagine how the source would like in such a graph.
Yeah, I mean, you can write broken compiler IR in every program on the planet, in every IR compiler on the planet, and then trying to reason about it is, futility.
For sure.
This is his power.
Okay. Well, then I'm going to have to spend a bit of time shuffling around with this graph, which I don't think I should do live because it'll be way too embarrassing.
Well, I throw in the 0 trip count version so you can see where your right hand current graph select composes belong hooked onto a 0 trip count test, which is not shown.
Okay.
And
so
that might clarify the situation.
All right. So the 0 trip count is an additional if, and where's that going to go?
Well, go back to the program code. Here, I'll go to the Google Docs and we can pull that up here in a second.
Okay.
But if I have control code that goes left and right. And along one path, something gets initialized, and along the other path, it never gets initialized. Once I rejoin, nothing should be out of scope, right?
If you have if and else, doesn't mean this if projection and else projection, something in the graph of nodes representation.
Right. So if I say if x equals 1, else x equals 2, then after the if statement, I should be able to use that x because it's either going to be 1 or 2.
That
But if I
should
say
be a
if
5.
x equals 1, else y equals 1, both x and y should go out of scope in those block ends because they didn't get defined on the other side, right?
Well, what line would, well, if you say if x equals 1, else y equals 1, then in the C-like language, you'd have a phi at the bottom where x was 1 or its original value, y was
much.
1 or its original value, and they didn't go out of scope yet. And I'm trying to remember the program that Darrick's working on, and I've lost the vision of it, and I'm busy writing the code for it.
Yeah, so if you have the paper, it's on page 88.
I'd have to go hunt it up, which I can go do. I probably should. This is GCM paper, global motion, code motion one.
This is no combining analysis, combining optimizations.
Oh, okay. Let me find that
I'm just
one.
opening it up here too.
That's not my PhD thesis, is it?
Yeah.
Oh. All right. I know where that one is.
Oh, wait. Oh, I seem to have found a miniature
Flip
version
is
of
red
it.
hat paper.
See, we're not talking IR95. Let's see. Maybe we are. Ah, yeah, there's IR95. Or some slight variation thereof.
Can we see it on the screen?
All right. Say one. Are you talking about my PhD thesis? Or are you talking about? Say it again. Global code motion, the paper.
No, this is the PhD thesis. It's the 103rd page of the thesis, but it's numbered page 88.
As soon as I pull it up, I will. Oh God, misspelled thesis by capital or lowercase, sorted badly, and that was why I can't read it. Fine. Now I'll go find page 88. Give me a real PDF reader. Why is Firefox grabbing this?
Okay, I've got it. Do you want me to just share it?
Yeah, just share for a second here.
Okay. So this is
Yeah,
this is what I was trying to draw.
I was getting there.
Yeah.
Right.
Yeah, I had to download it. I've got it on my iPad, but not on my laptop.
Yeah. I'm trying to write it into the Google Docs. I don't have the names right. So this is I and A, and basically I1 is equal to phi of what, I0 and I2. Yeah, pretty common, I2. I did a tuple format. Who cares? And I equals I plus B. Yeah. And some C is equal to I2 times 2. And I'll just do an if I2 is less than 10, loop. I'll invert it and say break to make life easier. And let's see. Okay. Other than like some numbering issues on variables and crap here, I got it in the Google Docs now. Yeah, so that's the version that if I were to rewrite that, maybe a little easier to read. I'll put that up front in the non-SSA version.
Yeah, let me share the screen that you're working on here.
While true, and we're going to print C, and I'll have C declared anywhere. I don't care. And I equals, oh no, no, yeah, here, wait, B equals, yeah, I equals I plus A plus 1. That's what that one is. And the key here is that C is I times 2. And then, if I is 10. Great. So there's a sort of classic C-like code with the damn auto completion from Google, like being in my face constantly. So that's sort of the code it looks like. The SSA version just renumbers all the I's around and broke it up into tuples.
Yeah.
So B is just like an extra tuple. And then the zero trip count version would say something like, I equals 0 and whatever. And then you'd have an initial condition that you want to do. So if you write it like I just did in the Google Docs, that gives you a zero trip count, but that's not what you can get out of the hardware per se. So you end up wanting to say, oh, it's not even a zero trip count. No, you're right. So it says if I is greater than equal to if it's less than 10, then do everything else. So let me actually just inline that one, because that one's easy enough to do. I can't do shifts. Google Y. Can't do automatic, breaking here. Okay, so now I have a zero trip count, right? And if I take this into SSA form, down here I'm going to have some I3 is equal to a phi of I0 comma what I2, and I'm going to have a C, which is a phi of the original C I wrote up here. So let's not be undefined. C is 0. Phi of C0 and C1. Okay, now let's come back through. C2. This is C1. This is C0. So every single assignment gets a unique thing. So in the version I finally put together, C2 has a merge at the end of the world, and this is the merge you're fighting with. And what you end up doing is moving this math here, which I'm going to leave in. Oops, Google, what'd you do? That was weird. You end up code motioning it this way, right?
Yeah.
And that's the desired get it out of the loop thing going on there. And you still have to do a merge. Let's see here. The if needs to, I have the if and the merge for the if in the wrong place.
So you know what? I don't know how I was looking at this code for so long and thinking that the condition was at the top of the loop, not at the bottom, and it didn't. Anyway, I was just misreading this code, and now that I've changed it, it code motioned the. Or I can show. I'll paste in what I've got and what it produced.
Okay, I think I'm done with my version there. I finally got SSA right, but fine.
Yeah. Okay, so right, yeah, it's exact. Yeah, I get it. So the multiply moves down to here.
Yeah, and now you have a select after the if, which folds the the empty else clause. I have an empty else clause, basically.
Yeah.
And it merges the empty else clause with the loop body clause.
Yeah. Okay. So let me see if I can. I'm going to paste some stuff in and then spend a bunch of time cleaning it up.
Yes. Which is what I did. I'm thinking on the fly. This is your live demo. Hey, live demo time.
Yeah. Oh, hey, it pasted in okay. I don't know what happened. Okay, so almost correct. Close enough. So that gets, actually it's not.
I and C are set. Yeah, okay. Yeah.
So I'll just sort of average out indentations.
What's the difference between do and loop? Do is just.
This is just a syntax because I'm actually starting at IR like halfway through the compiler just to feed it directly into the graph. This is the form it looks like when I feed it, like I read it into the graph.
Gotcha.
So then
this is not your post optimization because you haven't moved the multiply out of the loop yet.
Yeah. So then I run this whole, like, basically I run this set of operations on it. Basically this program, I run to graph, construct call sites, remove dead nodes, and prepare for scheduling. And then I schedule it. And then the output that it's giving me now is this. Okay, so basically all this stuff is the call definition. And then my basic blocks are here. So the main block is this, loop head is this, and then else, then tail. This is just sort of dumped directly.
And there's your ×2 in the tail side of things.
And the ×2 ended up in the then block. So that's awesome.
And then problem solved.
Yeah. Okay. So my question is, I guess I have to look at what the graph it actually produced is, but it seems as though when there's a select pinning, if a fee selects some value, that value is pinned into whatever block it's selected from.
It's lower, it has a lower bound use on the.
That's right. It puts a lower bound
edge to the block where it's getting selected from. In your case, the lower bound edge is the select itself. The select itself is stuck at the tail end of the block that falls into where you're about to merge.
Yeah.
Okay, so and that's what it is. It's a use. If you go look at your graph shape that you have, that's the left-hand side, correct, no zero trip count, you'll see the fees all have to be pinned in the block, but the head of the use comes at the block falling into the fee.
Yeah.
And that's an upper pin. And then the graph algorithm just sorts upper pins versus lower pins and picks a range in the middle and picks least trip count in the range in the middle between upper pins and lower pins.
Yeah. Okay. Well, I'm super happy that it's actually right. And I was just
worked on
running
a live demo when your hand rolled thing was not correct, which, many times I'm convinced myself I'm broken, followed by I work a long time and then I stare at it in the debugger and the debugger tells me, no, he didn't do this. He did the correct thing all along. Like, oh.
We need more SSA videos, presentations.
Yeah, I have the SSA version of the correct thing, just same as he has, but in LaTeX from the 80s. It's kind of, and then run through OCR and or PDF by photography.
I get some things I saw in the monitor. I couldn't quite get all of the intrinsics.
You want me to throw
Darrick? No. It's my SSA deficiency, not.
Okay. I mean, I can throw up another version of this. Sure, and I have the nice talks I did like a month ago.
Yeah.
And I'm actually going to give those in Italy. Because you guys make a great test audience.
Yeah, and you can continue make SSA presentations and CF nodes for the audience here.
Okay, I heard a hint there. The only issue is they just take some amount of work, which obviously is why all these things take work. Let me see which one of these gives me the better, because I have a very similar program, because obviously I'm doing a stupid dumbass, like it has to be easy to look at.
Yeah. Well, one of the things that I'm kind of wondering about is, do you have a pile of good example programs that you've sort of collected, or that
I have graph versions on?
Not that necessarily, just like programs of this level of complexity that test something interesting. Like when occasionally I'll do very simple, like, I'd set up a test for, an if diamond or one where there's like a nested if and do those. And
All right, I don't. And what happens instead is at Hotspot, I had them and they went with the code base at Hotspot, and AA has them and they're in my code base for AA.
Yeah.
And these are all tiny programs from a text point of view. I write them, I parse them, I have a test that parses them and builds whatever it's going to build out of them and then confirm shit. Let me pull up share here.
Yeah.
This is the similar in theory program to what you have. So it's got an initial, I don't quite have it right here because I'm not doing a zero trip count test. So I have the same graph, but my program I wrote in the middle is actually not the correct program. I need to do a do while. That's actually a good point. I should fix that. Here's my live, what here, X listen or something. So yeah, this is the same program you just showed us, more or less, morally equivalent, except I don't have the multiple by 2, which is invariant, which falls off the bottom. And because I don't have the zero trip count, you can't see where it moves down to it gets pinned by the zero trip count. So maybe that's a good answer, and I should be prepared for that when I show this. I clearly have a bug here, and then I go fix my program. This is an example. Hey, I'm building SSA. I could also add the loop invariant value that shows that it falls out the bottom. The goal for this talk, I'll sort that one out. The goal for this talk is to say, here's how you build it, not here's how you come out of it. You had an issue somehow where the program was coming out correctly and you convinced yourself it wasn't. Because the loop trip count was not correct, because perhaps my text format written was not correct, just like I did it here. I didn't do a do while loop here, and I should have.
Well, I don't think there was in the paper an actual text source of the program. It's just this sort of block thing.
Yeah, block diagram.
And so I just misread.
Missed the
that
thing.
loop.
All right, fine. Yeah, people normally expect to have an initial condition, but when a compiler goes and generates code, the basic blocks and the graphs they get almost always have a zero trip count, which doesn't show up, obviously. Like way back in the day when I was talking with C guys and C compilers were new, there was complaints about, what that meant and performance and whatever. You didn't write what you got because you had a hidden control flow edge. After a while, everyone just ignored it, got used to it, ignored it, moved on. But yeah, you write a while loop, there's an initial zero trip count test. You do an example loop for a compiler, you rarely write the zero trip count test. And then the difference between I don't write it when I'm doing the compiler and I do write it when I'm writing the code.
Yeah.
Very annoying.
Yeah. So actually it's kind of interesting. I do a very early pass. It's actually a macro expansion for things like while loops or count. I do times and count down and stuff like that. It turns everything into this loop construct, which is also available in the source. And so it's basically like a loop. And if you don't say recur is basically continue. If you don't say continue, it falls out the bottom. So that's you kind of have a break. Just you always fall out unless you continue.
Right.
It's actually a pretty nice construct. I learned about this one from Clojure exposes this in the language as a low-level loop primitive, and it's pretty nice. So it's been pretty good to build on because the structure is pretty obvious in terms of where the basic blocks in this would be.
So this is my thesis, page 97 or 98 or something. And the only thing I'm pointing out here is at the end of the loop block on the right, the basic block on the right has branch not equal loop. That's, we're headed for the hardware level. if you don't branch, you fall through. So you must have a branch.
Yeah.
So if your IR doesn't have a recur or a continue or whatever, you fell through.
Yeah. Yeah, exactly.
Yeah. Okay. That was all I was showing here. Yeah, this is my LaTeX from the, late 80s.
Yeah. And I think I get that add A1 moved up to the top, just like you have. And
Yeah. Okay.
yeah, I'm
Yeah.
pretty happy. Like the algo
There you
was pretty easy to implement and works awesome. And now I have, so I basically did this as an early exit from because I had all the tail end passes built. And I don't have a really wonderful register allocator, but I have one that works, sort of, I think. And so I've got a lot of people who just want to see working code. And so
Yeah.
rather than spending a lot of time getting things like really good with optimization and stuff right now, just basically I'm going into the sea of nodes, doing no transformations and coming back out scheduled. So the only transformation I get is the code motion.
You get code motion.
But if I can make that produce running code, then everything I add in the sea of nodes side from here on is just going to be benefit.
Yeah. There you go. I totally get that.
Yeah.
I did that hotspot umpteen years ago. It was all like, when's it going to work? When's it going to work? So you went end to end with really crap stages in the middle just to get it end to end, to get people to see something. Yeah.
Yeah.
And then they did pretty good.
Yeah.
Anyway,
it's exciting. It's fun when things flow like.
Yes, get it working so you know if you broke it. Yes. That's where I'm at with AA's typing, with overload typing right now. I thought I had it working, it's broken. So I'm re-theorizing, which breaks everything. And I can't tell if I'm broke or not broke, because everyone's broke because the theory's wrong at these corner cases. That just means it's wrong. So you have to go back through and get it sorted. So all test cases all work except the one, or I'm in the middle and all test cases fail. And if they make changes, they still all fail. And I can't tell shit until I get something, sort of squared away finally. That's what it is.
Yeah.
What was I wrong about? There were two little things that weren't so little. The one was, I found a case where it was ambiguous and I needed a user syntax to break the ambiguity. The typing system could not break the ambiguity. That was obnoxious. That's actually a good one for the Google Docs here. And the other one was my attempt to break the first one was done by, let's see here, there. I'm going to share here, hit Google Docs, try this. Let me come down here. I need to have another one of your boxes. How do I clone? Here's a box to clone. The other one was if I was deciding that, I was deciding that the easy semantics I wanted to have here was that overloads are effectively a tuple where you don't name the element of the tuple you want. The typing system picks the correctly typed tuple, of which there can only be one, or you have an ambiguity error. So it's just a tuple that has missing a field load out of the tuple. I'm missing a slot 0, 1, 2, 3, 4, and the typing system picks it out. So let's see here if I can remember my ambiguous test case off the top of my head. I have it in my, I think I have it in my test cases here. All right, it's really short, obviously. These things only get short. That's not the one I wanted. And then I have to do it from scratch here, and it'll take longer to sort out which one's ambiguous and which one's not. Oh no, I had it in this test case. No, one is not overload. Overload 0, overload 1, 2. I'm finding it. I have it. I remember writing it. Some variation of this guy. what was the issue with this guy? I wanted to say it was like some function took an A and decrement A. This is me writing lambda calculusy things, and then I overloaded him with okay, so this is ambiguous in that I can resolve it in one of two ways. And I could either say over needs to select the first element of the tuple, so I'll put a .0 here, and fun takes an int. So let me write this way here.
What's the signature of dec? The decrement function.
The decrement is int int, subtract, add, any integer int. Here. I'll change this way. All I want is to force yourself to do something. Okay, so here's and the .0 I put on the over in the second case is where I resolved. And then the other version of that is here. So an overload takes an int and some other things. I don't care what, as long as they're unambiguous. And
how do you deduce that A must be something? It's a tuple. How do you deduce that it should be an overload?
Well, A can be an int, or A can be an overload that contains a unique int. And that's the ambiguity. So I have to solve the ambiguity. So that was one of my problems.
How the information you get from here is that A is something that can select 0, so it's a tuple.
I added the, I'm sorry, go to the first program of the three. What is the type of F, of fun?
If a dec is an int, then it should be an int to int.
That's exactly what I'm pointing out here. Yes. These are all the same programs plus A1. Okay, so I could resolve function to be int to int. I can resolve function as taking an overload with an int to an int.
So in this case, it's too little context in order to resolve.
Too little context to resolve. In fact, it's ambiguous. I can go either way. In this case, the program gives me the same answer in the end. But I've come up with versions of this same problem where it's more clear that I need to figure out how to do it. So that's not fair. I have examples where I was getting myself confused and then deciding that because it's ambiguous, but it gets the same answer in the end, I had no way to test that function was typed, fun was being typed correctly, but I could verify the entire program was typed correctly. And where the resolution happened could move around. And I didn't like that as a programming language, as a typing system. So it's a valid typing to go, the entire thing is typed as an int. And internally, I don't tell you what those types are, and you can't make a reasonable judgment because it's ambiguous whether the overload is resolved early or late. In most of my other examples, the overload has an obvious single point where it must resolve. There's no ambiguity about it. And I get really nice looking code. And also I get all types for all things in the middle. I get a single best answer type for all parts in the middle. So when I hit the ambiguous case, I got like stuck there. And then the next thing is that when I was working my other test cases, which were more complicated and looked pretty, did the right thing, I did them by declaring that I wanted to have a single point where I resolve the overloads. At the point I resolve the overloads, the flow type changes from being a tuple to being a member of the tuple. It's basically, I inserted a load. If I inserted it lazily during the algorithm, the flow types for parts that would have otherwise been monotonic changed in a non-monotonic way. They went from an overload sideways to a member of the load int. Right?
Yeah.
And I lost my monotonicity property.
I
And because I'm
may-
ambiguous, it could happen anywhere.
Mhm.
So between those problems, I kind of like, grit my teeth for a better part of a week and tried a bunch of things. And maybe I have an answer now where I'm just going to demand the overload has an obvious place where it gets resolved by forcing the user to put an annotation if it would otherwise be ambiguous where it gets resolved. Once it's resolved, at that point, I'm all good. I'll make a pass or pre-pass or whatever and jam my load in, basically field load, put my field load in where I resolve it, and then I'll type the damn program after that. But the first step would be get rid of the overloads by putting in a field load at the appropriate place. And then, then after that, I don't have any funny overload resolve issues other than the one that says I pick the correct field based on type. It's not, I'm going to remove the type system solves where you resolve it. Right now, the type system is picking where and to what. And I want to get rid of the where and just let the type system pick the what.
Because it cannot be monotonic if it have a where.
Yeah, if the where comes along, what I would have to do is make that actually rigorously fixed, and then I can be monotonic. But as soon as I'm rigorously fixed, I might as well fix it ahead of time anyhow.
My hunch is because you can go a separate flow within your resolution, and you constantly try to make progress, jump to another try to make progress, put your neighbors back in order to they will pile up until the program resolutes. And if that can be dictated and unambiguous, then it's over. It has to know which function has to pick.
Exactly. If I get that all works, by the way, in general, except for where I got this ambiguous case.
So if you find ambiguous, demand the syntax direction.
So I'm going to demand a syntax change somewhere, and that's going to tell me whether or not, I think that's going to tell me now without actually being clever. I'm hoping I can get a syntax change. That means without actually being clever, I can know where the resolution goes. And that means that you can look at the code and know where overloads are going to get resolved. That's one of my goals, is to not have a type system pick the where, because the where makes it difficult to understand where he resolves. So instead, I want the program to be syntactically obvious. This is where overloads resolve. Which one they resolve to, that's down the types, which hopefully that's pretty obvious reason you're using overload, is because it's an easy one to do and it saves you some syntax and some typing.
So that's fair enough. So as long as it's not ambiguous, we can go forward. So
yeah. So I have here's a more looking at somebody else to say, here's a more interesting test case with a lot of Google lost it here. Yes. Want all of that? Yeah, I did. Okay. Now I have too much junk here because it's the middle of a Java test case harness. Wow. And let me go ahead and do this. And this will actually be cat light. See my parens. And that's just reporting something. I don't have any print bounding, so I'm probably not getting it right here. This, yeah, something like that. So it's like define makes a color overload.
Yeah, that would be good to go line by line to make sure.
And here's some colors. Right. So
the first line is a color that has two parameters and return an overload that can either return a hex or a name. Is
Yeah.
that correct?
Yeah,
Okay.
yeah. So color is a function which takes 2 arguments and returns me an overload. Then red is
can-
defined to be color with some hexadecimal bits and a string.
Yeah,
And
at
I
this
take-
point, the overload they can figure out that this is an int and this is a string.
Yeah, the makes an overload, which is a pair of either an int or a string, you know, a tuple with an int or a string. Then when I say light, here we go, get rid of the dot zero. When I say light, this version of C that I've highlighted is known that it wants to be the int out of the color, and the other one wants to be the string out of the color.
Mhm.
So C is a local variable in the light function that's an overloaded color. So that wants to be an overload. The C wants to be an overload. And
These
then-
are the arguments to the color. If I'm
yeah, and then I have 2 arguments to the color. One's an int, one's another string. One's an int that did by subtracting from the color, and one's a string I get by string concatenation.
Mhm. So what does light returns?
So light returns, light is a function. Light equals open curly, it's a function.
Mhm.
So the function returns me another overload. It takes an overload and returns an overload.
Mm,
So this is typed as an overload returning an overload. The function takes an overload, returns an overload.
Mhm.
And this guy, you know, is a function that takes an int and a string and returns me an overload. And yeah, it's an overload of int and string.
How is
And
this
then
different?
the
tuple?
2 colors are there. And then you can go use, you know, use red where you want to have the number and use red where you want to have the string without having to say dot name or dot hex value. That's the goal there, is to of overload. So I have the case that got me down this path in the first place was I was doing overloads on operators where I wanted to have you not have to pick which operator function you meant, but I could tell by the typing that you meant int plus int or int plus float or whatever.
The fact that we use C in both contexts, it shouldn't be this a problem for the light function.
This one I can resolve, but it means the function argument takes an overload. In the case above with fun and over, I have the issue that I don't know whether fun takes an overload or not. So I can't infer in all cases that you're taking an overload or not.
Can this say interpreted as this takes a tuple with the first being an int and the second argument being a string? Can this work out?
So light takes an overload. So the difference between a tuple and an overload is simply a tuple will not let you automatically resolve by a single use.
Mm-hmm.
The tuple just throw syntax error, because overload I think would be like an odd thing, except specifically you wanted to have this kind of game going on.
Mm-hmm.
So you have to overload is typed differently than a tuple. Otherwise, an overload is a tuple where I've inserted the field loads for you. That's what it amounts to.
So the light in this context can figure out that this is returning an overload because of the color signature here.
Yeah.
It can figure
light
it
knows
out.
it's returning an overload. Now,
Mhm.
is light taking an overload? Well, if light were to take just an int, the cat of light and an int would fail as not correct. And if light were, as you know, the argument C was just a string, then the subtract of the string in 101 would also fail.
So it can deduce that the C must be either a string or either int or a string. It cannot be both at the same time.
What it deduces is it can't be an int or a string, or you get type error in both those cases. So it must be the overload of int and string.
So this is some way to cheat the intersection type. It can be either an int, either a string. And so
yes, I'm basically trying to cheat an intersection type, and I've thought about this for a while, and I don't really want to go there. So I'm not saying int or string. Instead, I'm saying delay the typing of light, because I have an incremental algorithm I can do that, until it becomes apparent from use cases that light is being passed an overload.
And maybe here is the problem. In essence, that's what you're trying to do. This is an intersection type because it can figure out. So it at this point it say, I will create an overload for you that can be the intersection of both types that can maybe made work.
Yeah, and maybe that's my fault, is I should just give up and say I have an intersection type and deal. Right now, what I'm doing is I'm not saying I make up an intersection type for you.
My hunch is that you're using overloads this way, but it's all purpose to resolve the ambiguity, not to try to work around it.
Right. I want to say you only get an intersection type and overload when you ask for one.
Mm-hmm.
Now, having asked for one, I'll follow where it went through the types, and therefore I'll understand that light gets handed overloads.
So here, either we here annotate, so it knows it has to deal with them.
Yeah, in this case, I can know, and I don't need any annotations. In the case with fun above, I have to be told.
So because this is an easy escape hatch, because if the compiler, if the Hindley-Milner or the compiler can figure out the type, it says just some kind of overload, and just
as soon as I know it's an overload, I'm good, because everywhere I use C, I'll put in a dereference, a load out of it, field load out of it, to make it, go away as an overload, and it's done. Except it's not actually that simple, because when I call light, I'm being passed an overload. So it's not every application point, every argument to every application point that has an overload resolves it. Some applications want the overload to pass through. Some applications, like subtraction, have to take the overload and resolve it immediately. And I can sort this right now pretty readily until I got ambiguous. And then I had algorithmic issues I didn't want to deal with. And the way I was dealing was lazily inserting the loads where I found them. And that got me to thinking that I actually want to have a well-defined places where the overloads are resolved, so that a user can look at his code he wrote and understand where the overloads get resolved. And now that requires a syntax change. And that's kind of where I ended up, and I'm sorting out what it is the correct syntax change to do here.
So in retrospect, at least to my knowledge, if you declare, let's say in Scala, if you declare an overload type, you have to declare its type. It knows with which types it deals. So so in order to pass them, let's say with the same name.
So with color, I can deduce that it produces an overload based on its two arguments. And I'll eventually deduce hex and name, what those types are from their uses.
But this is essentially a tuple from unknown type to an unknown type, as I understand.
To an overload of unknown type. This is a tuple. Yes. You look at color in absentee or by itself, it is a function that takes two unknown types, an A and a B, and produces an overload of A and B.
So with that.
Yes, and in the further context that moves forward, color gets used where the A and the B are known to be, int and string.
So you can pass the red to a light and blue to a light, and it will maybe resolve it.
Yeah, by the time I pass the red and the blue to a light, sometimes the bottom one I can totally resolve, and you don't quite have this thing right. That's the return. It's just like a function from A. Here, I wrote it out the back. Let me go write that in general types. I pre-did what you're doing here, but it's really a function from A to B to an overload of A and B.
And here the question is, does this really an overload? Because an overload for Scala, it's a function with a name that first argument is a different type. So it knows the different type.
Do you have a syntax that you've done in Scala to force it to know?
Oh, should I say it? No, that's not quite correct. I can write a generic function, let's say overload from A to B, and it asks its two arguments from A to B, and it returns A or B if you want to emulate the intersection types. And you have another function overload that's, let's say it's an int to A is an int in this case, B is a string in this case. I don't know what would say Scala in this case, because if you have an overload 1, if you say an int, so let's say here, def overload 1 with an b with a string, Scala can resolve them because it knows the first argument for the overload in this case is string, in this case it's int, and it knows how to disambiguate them. But as soon as the types are general, I don't know how the resolution would work.
Okay. I don't know that. Well, maybe.
I completely don't know even how what Scala will say about this. I have to check.
Yeah.
The first color signature is equivalent to this type. Right. Some unknown type A, some unknown type B. You have both an arguments that respect. I maybe should rewrite them to your code equivalents, but in the end it returns A or B. And later you have another definition of an overload that the first type is int, the second type is string. Show how to know which overload to use for if it's an int and string here, then it's the more specific type. But if it's on something else, it should be treated as the first overload. Let's say int and an int. And how at this point it should be able to disambiguate them because it knows the types you're passing in. But at this point, the resolution of overloads goes so far, at least to me.
Well, if I call color with 2 ints, I'll get an overload I can't disambiguate.
Mm-hmm.
If I then try to use that color, I'll get an ambiguous overload error. So I call color with a 1 and a 2, and then I come down here and I say, tell me add bad and 3, and what do I get? Well, the answer is you get a ambiguous error. Because a color produced an overload that can't resolve.
So shouldn't you get an ambiguous overload error when you generate an overload that has 2 identical things in it?
Well, this is an AA design decision that I decide that bad types don't end things if you never use them. Dead code, bad types and dead code are okay.
Oh.
So if your code is dead, like if I just define bad as a color of 1 and 2 and never use bad is dead. Okay, bad has a bad type, I don't care. And in fact, when I say I can't resolve in practice, what it means is I have to attempt a resolution with something. So here's a version that it is okay. Let me show you this guy. Okay. Color has 2 ints and a string, and I use it in a string context. Well, I can resolve that one. I'll just pull a string out, I'm done. So that overload's not bad directly. If I pull an int out, I am
in that case.
Here,
in that case, are the int values that you put in it lost forever?
Yeah, they're not usable. It's a type error to use them because I can't tell which one you mean.
Mm-hmm.
So if you throw something in a overload and it's ambiguous, if you're care, you're going to use it, you'll get an ambiguous error and you have to go fix your code. Right? If you accidentally throw things in an overload that you're not actually using, life will go on. But I think that'll be the odd case, that'll be unusual. It's like, if false, then something stupid. Okay, and you test this code. Well, if false kills the something stupid, you never run the something stupid code. You can't tell. Like I see this all the time, actually, in large, complicated programs that I'm pulled in to go do some fix on or whatever. Somebody wrote a bunch of code that's error handling, and the error handling can't happen. And the error handling code is clearly wrong, and they're busy trying to fix bugs in the error handling code. but they can't because it never executes because you can't get to it because that particular error handling doesn't happen. Or it's the other way around. The error handling code's never tested and it's broken, but it passes a type system. But as soon as you run it, but whatever. I mean, you got bad shit in dead code. What do you want to do about it? Okay, fine. So I'm claiming I'll just let it be bad crap in dead code is okay for a different reason, and we can argue that's a stupid decision or not. There is a way to overload my odd overload there that is correct, and there is a way to say it's not correct. And I don't know that I could tell them a bad one without a use case, and that maybe I could try overload resolving everybody against everybody in the overload, and if any two pairs do resolve against each other, that would be ambiguous and I would blow up. Maybe I'd have to go sort on that one more to see if that one's actually going to hold water.
Yeah,
I wrote a trivial example, but
then you'd probably have problems where really generic things like hash code function overloads on anything, and then you blow up on everything.
A function, an overload resolves functions on arguments alone, not on the returns. So if you put a bunch of things, you can hash, generally you can hash almost anything, and then if the existence of a function called hash that can hash virtually anything is in your program, then it would prevent everything from being created if you did that. Yeah, I don't have such a thing that Java has, where Java has a default hash code. You can write a hash function on anything. You can call it hash if you want. That's a nice way to call it. It's a function. You can make an overload of unrelated hashes, but all those hashes will have a first argument of the type of the thing you're hashing. And all those types have to be distinct if you're going to put an overload. If you're overloading cats and animals, then I'll probably give you an ambiguous error and say I can't tell cats from animals because cat is an animal and it'll resolve. So that will give you an overload ambiguous error.
Yeah.
However I define animal, I define cat as an extension of animal. They both have hash functions. I put them both in an overload. I'll claim, cat resolves to the hashes overload, to the animals overload. Cat resolves to the cat's overload. Don't know.
Well, it's interesting because sometimes you want to generate an error somewhere to find where something's happening. And you'd have one avenue in this language is to just make an overload ambiguous intentionally. And now whenever something's hitting the thing and you're wondering where it's getting hit, it's like kaboom.
Yeah. Put a type error in and have the type error show you something.
Yeah.
I claim the IDE is supposed to do that for you.
Right.
But maybe not. Go find where this thing is being used but maybe, okay. I do that technique, by the way. If I'm trying to find all the possible things where some X stupid Y happens or whatever, I'll rename a variable, rename a function by throwing like a capital Q on the end or something stupid, and then run the build, and it's sort of Emacs that goes instantly quick, and you've got all your errors where you used a thing, and then you can ask IntelliJ and it does the same thing. And I don't know that it's actually any more or less convenient. It's actually typically less convenient for me to use IntelliJ, but only by a small amount. I don't know. So my current story is I want overloads to have a single resolve point and have it be more obvious than have the type system sorted out completely. And that means I have a textual game that a syntactic game I need to play.
To add to the Scala example, if I try to quickly write into the terminal, if you don't know about A and B, how you would define it is the same here. If you don't use the hex with some variable sorted into a string to deduce that hex either be a string or int or something else, I couldn't write this Scala. I tried to, I don't know about A and B in order to even define the function, be it that the next always definition should be an int and string. This is easy because you know the type here.
So is an overload in Scala an actual intersection type?
No, the overload, the compiler handle then is with a function with the same name in different first arguments.
So it's a function with maybe different arguments.
Yeah, you define the function with the same name and different
All right,
arguments.
I blame Alan because I started out by saying all my overloads were just functions,
Mhm.
and I would distinguish by arguments and not on the return. And originally I said, well, I can go distinguish on the return as well. And then Alan popped up and says, well, what do I need a function for? I can just go distinguish two different things. And I was like, oh yeah, you could. So I got rid of the function requirement and just distinguished random crappy things.
Hmm.
And that all kind of worked through the machinery up until I hit my ambiguous error. So this is Alan's problem. I mean, this is Alan's fault, not Alan's problem. This is Alan's fault.
So Alan is obligated to help.
I wouldn't mind to help, but you know, he's not obligated. And of course, I'm leaving on for vacation starting tomorrow. So yeah.
Okay, so
start helping.
if you want my advice, I would reject the light function that takes the color and uses it as an int in a string, and I would reject that. I would give it a type error. It either has to be one type or the other, like throughout the whole program. You don't
Well,
resolve.
that's the whole point of an overload. Is it's a collection of things. It's think of an overload really as it's a tuple or a struct or a class where I'm naming which field you're going to pull out based on context. You're going to pull one of the fields of color out, of C out.
All right.
That's what it is.
But like,
But-
I mean, the point is that it has one value, and you're saying that value is an int and a string, and so like,
No. Yeah,
much more-
that's what it looks like. And that's what I started with because I have a use case for this kind of thing that's a very common use case. That's the overload resolution for primitives. And instead of morphed it into it's a tuple, I'm going to pick the field for you.
well, see, that's where it's very complicated. See, like you actually want to represent tuples as tuples and like restrict the overloading to functions. Like I was
You know, the same machinery works here. Once I have overload resolution on functions, I have it for everybody because I have the resolution based on the argument types of the functions. I don't need the function, I just the argument type. Well, that's just a bare thing, like an int.
all
So the
right.
machinery all works for having anything you want there.
I mean, like, yeah, I'm not saying your choice is bad. I mean, in my language, an overload is just a completely ambiguous value, and it only gets resolved when there's an error. Like, I mean,
Here, to classify for the ambiguous, you have to have another definition of color, and the compiler should distinguish between this definition and this definition. Defining here is just, at least to me, I may very well may be wrong, is just an intersection type.
No, it's not what I'm doing.
but it's not an intersection type because you have multiple values in the type. And then
Yeah,
you
it's
can-
not an intersection type. Literally, I'm making a tuple. I started out thinking I need an intersection type. Then I was thinking, but wait, one of my goals is to pass primitives like add and subtract to another function to be used where I have to resolve int plus int versus float plus float. And I wanted to pass a primitive add along and have that resolution at the use point. But there are going to be multiple uses, multiple primitives, one for int plus int, one for int plus float.
Mhm.
So therefore, it's not a single value, it's a tuple. I'm literally making a tuple. Replace my syntax for ampersand square bracket with classic tuple syntax. Here is a tuple I'm making. Okay, now I'm making an obvious tuple. Does that make sense?
Mhm.
Okay, I mean, you can argue application versus tuple syntax, but there it is. It's a tuple. So when I come down here, color is typed to be a tuple.
Mhm.
Well, I can't add a tuple or subtract a 101 from a tuple, but I can subtract it from the zeroth field. So the only thing I'm resolving here automatically for you is which field I'm going to pick out. And it's unambiguous by context, by the typing. So this is basically the first, and here is the second, and that's how that typing currently goes.
But if this is a generic type, it doesn't care what you will pass. It's still count
right.
as a tuple.
The color itself is a function with generic arguments returning polymorphic generic types,
Mhm.
which I can put into a tuple.
Hmm.
As long as the 0th field and the 1th field align in their uses. So I then call color with red and blue. I get two tuples out, one red tuple, one blue tuple. Both those happen to be typed as a tuple of int and string.
Here, yeah.
And then they're passed into light, where they're typed as a tuple of int and string, and then they're pulled out, the int and the string part are pulled out independently. So it's sort of like super simple if you go to the tuple model of things. So if I claim here, what is the type of red? Well, the type of red is an int and a tuple of int and string. What's the type of blue? Tuple of int and string. Okay, and this is all type inferencing do it for me. What's the type of the argument for light? Well, type inferencing will tell me, I don't know, types an int, a tuple of int and string. Fine.
No, the input types can still be. This is the first argument from the tuple. This is the second. The return type would be for sure int and string. Here.
Yeah, the return is call color, where color is a function of polymorphic, but given an int and a string. So color. So the return from light is also a tuple of int and string. So I mean, I'm overloading. We're having issues because we've got nomenclature and overload. Overload for me right now means it's a tuple, and I'm going to pick out for you which fields. Turns out I have to pick out also where a little bit. I need a little bit of help to figure out the where. And I'm hoping I can get away with just declaring overloaded function arguments as overloads. And that'll resolve the ambiguity I have up with my fun discussion earlier. Function.
So just out of curiosity, if you have an overload and one of the things inside the overload is a function, can you just call the overload directly?
Say again?
If one of the things inside the overload is a function, can you call the overload in the function position?
Yes, that is exactly the goal. So the goal is to say something like, I have some prim add is an overload of $int and a dollar. I'm doing dollar for primitives. Int float. So here's an overload that says I'm going to do some. I gotta go take my medicine. That's what it's telling me. And then I want to come along here and say, 3, prim add 4 as an operator. Equivalently, I could say a function prim add C syntax 3, 4. Equivalently, in the lambda calculus I'm using, it's prim add 3, 4. All those are the same, and it just resolves out to what it means to add the int plus int for an int. And also, I could have said,
how can you decide when the infix position is valid?
Well, in AA, so in the core lambda calculus, it's never valid. In AA, the infix's position is because I'm doing add like this, and I define an operator add, which has a funny syntax. The underscores tell me that it's an infix operator.
So can I stick underscores on anything and make it infix?
You can define operators. Yes, you can define operators. There are some rules that make it syntactically correct, but you can define operators. Okay. And use them with and without the. That's only valid in the infix. If I do it in prefix, it's just its name.
Okay.
Lambda calculus does it this way and never allows operators or anything. That's a parser hack. That's just an AA parser hack. Not
sorry. Just curious about that. I was sort of like off topic, but
yeah. Well, the goal for me was to say this is a function. These are the primitive functions, but internally it's a function of A and B arrow C, except that A is defined as an int and B is defined as an int. I'm going to return a C, which is an int, and that's one of my functions. And it's all combinations of int and float here. So here's an overload, and
so you could just have one giant overload with every variation, and then the type system will pick the right one.
Yeah, and you can also pass then the operators along as a function-like thing. You can mix operators in arrays and pass them along as polymorphic, whatever. You don't care, you don't know, and then effectively you're actually handed more or less a B table.
Yeah.
And then V-table
And then
resolution
just for
happens.
fun, you can stick strings and all sorts of other fun things into this and do weird.
Yeah, I could make
you
it,
can
I
also
could
treat
make,
it as a color at the same time.
yeah, the operator overload for add could do strings.
No, but I mean that you could actually also stick your color definition
Yeah.
guys, an actual integer and an actual string in
Yeah.
this same overload.
Yeah.
And it could be all of your infix operators plus it's red.
The name, the pretty printing name plus and all kinds of shit in there. Yeah, right. As soon as I sort it all for any argument, I can sort it for a function of arguments. I can sort it for all random crappy things on the planet. I claim, I think there's it increases typing time by a factor that's probably squared in the length of the longest overload because I do an all to all periodically. So it's not necessarily what you want for,
Yeah.
or, you know, and there's a clarity in whatever, but my original goal was to let me sort out expressions like 3 plus 4 versus 3, you know, plus 4.5, right? And I can overload resolve those and also pass them as a function object like plus to a map call on an array of floats, and it will do reductions on the map to just, you know, I want to write a reduction operator that just says, hey, take an array and add all the elements together, and whatever, Saxby, Daxby, variations of things.
Right. So in this overload, normally I would assume you've got a compose function, but you're not going to be able to compose addition in because it'll be an ambiguous overload.
No, you get an ambiguous overload out. Not ambiguous, you get an overload out.
But like I did compose that underscore plus underscore with I don't know, increment, like an increment functions, like
Yeah.
So then it's like plus one more than your thing, but you couldn't do that because it's an ambiguous overload, right? Unless you like write it as a function directly. But like,
well, I'm trying to make sure I get what you mean by compose here correctly. You mean something like, hey, I want to make a function which I actually want to make a function which.
Well, no, I understand that you can compose them in that way, but
yeah,
imagine so. Well, maybe you don't have this function, but I assume you do. A compose function that returns the composed function uncalled.
Right. I do that effect, but I don't have the compose function, but I don't need it. I can get that effect. Where the hell did I do that? I have test cases for that shit too. It's even called composition in my piles of test cases.
Yeah,
And that's because, well, that's currying.
It's all right in here what I meant.
Yeah, write something in here without, but like this is just a pure lambda calculus, right? Do a compose in pure lambda calculus.
Yeah, sure. So
you want to take the operator itself. Yeah, increment add, okay. Well, what is define compose? Inc, yeah, and plus. Okay, now define compose, because I'm just doing a pure lambda calculus.
right, okay, so yeah, let's see here. I gotta try and figure out
Yeah,
here.
you're taking two functions, taking F0 and F1, A and B, fine. And
Yeah.
now you're
I'm
calling,
say,
and you're going to return a function which takes the arguments to the operator,
and
it's going to apply the one and the other.
Yeah, and
you got to return a
actually
function.
no, I need to return another function. So
yeah, put a curly in there, curly brace, and then X and Y. Yeah, and then X and Y for the add. Yeah, whatever arrow. Yeah, right, fine. Yeah,
and then
B does right X and Y, and close and close and close and close and close and close, and you're done. Yeah, I do that.
So
what is the type of compose?
Well, so if I write this directly,
What was the type of increment add? I guess that's the better answer.
yeah, so this uses, yeah, I guess that would,
The increment add is typed. Let me go do that.
yeah, yeah. So the XY become the same as the arguments to B, and so the typing just flows through.
Yeah, this should just give me a type of an overload of functions. And you're always going to return if you compose it. So the increment has to happen first, or you have a float int error.
Oh, I guess it would constrain you to only things that return int.
In this case, you're composing an integer add, specifically integer add, not a +1, which would take a float +1 or an int +1 is fine. You're specifically saying integer add, you restrict it into yes. So instead, if you increment first, and my example is the left-hand argument happens to always be int. It doesn't need to be, but my current example on the screen, the left-hand argument is always an int. You could increment first and then add later. So I'm going to claim that you.
In my definition, I was saying the increment happens on the result.
I understand, and that makes the problem trivial in that I would say you have an error because you're trying to add one. You're trying to increment a float. There is no function for incrementing a float.
But some of the overloads of plus would work.
Yes, so if you reverse increment here, like this, and so the increment comes first because of the way you've got the compose written, if I did that right, yes. So the increment says, says increment the x and then go to the y. He would say, you have a same thing. It's going to be typed as an int, a function from int to float, int arrow float, and a function from int float. Oops, I get it wrong. Arrow float. Okay, fine. That's this version.
Yeah.
But I claim this is all. These are good examples for me to go test on. But these are all standard Henry Milner. I'm going to do your analysis thing.
Yeah.
I flow overloads through functions. So it's just a matter of where the resolution happens, whether I do a .f0, .f1. I'll go run an extra test case. You could be right. I could be screwed up here. I should go verify. These are good examples. I believe, oops, that's me fixing that. I believe I've got this right in the typing, and this will not cause me any trouble at all. But trust but verify. And if you move the increment up front, then what's it do? We go back to the original example, increment up front, what's it going to do?
I thought you did a resolution on the result type of functions anyway. So you just narrow to only functions that return int, but int, so you like int would still work.
Yes. Oh, that's the question becomes, where does the overload resolve? And maybe that's my problem here. This is probably a good example for me to decide. Maybe I can't pick a point where the overload resolves so easily. And you're right. I could totally handle this case. Actually, compose needs to be written first. And we could probably pick different, easier things to do than 2 argument functions here. Because in this example, as with the increment first, I would take the overload of plus and resolve it. Okay, yeah. So let me go write this as where the resolution happens. So in the problem case where the increment comes later, the overload resolution has to happen here, and I just decide, oh, you're an int function, and then I add 1 to you to the result.
Yeah,
that's where the resolution goes. And if I take the example as written above, you can imagine that what I want to do is claim the increment works on the left-hand argument all the time, and the end result that comes out, actually this result that comes out here, takes an x and y and returns me like I want to say it's actually going to return me an int. And this one returns me an int or float. And now I probably have to have a ambiguous resolver here. Like this one, I can stall the ambiguity longer. There's no resolution needed yet because I'm going to add one, and then if the second argument, if y is a float, you'll get a float, and if the y is an int, you get an int. So I can stall the overload longer. And the second example I wrote there, I'm immediately fail on the one of the overloads, so only the other overload works. So you can imagine it's resolved up front, and I get a int result only. And that's a good test case for me, yeah. That guy returns, and that whether I pick one or the other depends on the typing, not the syntax, which means I can't do it. I can't do it based on a syntactic form. Or we have to argue whether I want overloads to resolve in the typing system only, or based on syntactic choices. If they do it on the typing system, I have to go back to my original problem and claim I'm lazily inserting resolution, and at the time I insert it, I've already sort of made a mistake for the flow results, or I have to stall all flow results until overloads resolve. Maybe I don't have a fast, cheap algorithm yet. Ig. Well, we're 12:45. I'm way over. This has been an exciting conversation, but I don't have a good answer right now. So I have to claim I'm going to think on it, and I'm going to fly on a plane in a day and a half. So it'll have to happen while I'm trying to not sleep on the plane, or I fail to sleep on the plane, or whatever.
So
thank you.
Yeah. Oh yeah. Give you something to think about. Oh, by the way, I discovered I had an annoying problem with my going back to Sea of Nodes. I remember, I don't know if you want to talk about this, it's getting really long, but I'm okay too if you want to.
Do it now, or you're going to wait 2 weeks. So maybe
okay,
it's a quick one. I'm hoping it's a quick answer.
It's a quick one, I think. So basically, I had well, I'll show you actually. I'll pull up this. It's quicker if I show my screen here. So I've got this. Where is it? Call site construction thing.
Yeah.
And so I've got this all figured out now. So when I do a call, when I originally make it, it's a call, it's got the arguments, but then I have to go through this call site construction pass and actually change it so that the return comes into the call. So this becomes a marker of where the end of the call is. And then I change these to not be use def edges to the arguments. And I make the arguments just have one use def edge that ends up going to the actual function compose arg.
Okay, so back up for a second. When you say you're defining a call, are you defining a call site, like an apply?
This
or
is a call
lambda?
site, yeah, this is an apply. Yes.
An apply. Okay, so add an apply.
So I've got two functions here. I've got this do a, and then I've got another function up here that's calling it. I didn't give it a name.
Okay, I claim I have way simpler, and it's all use def edges, and you've got something else. There's no return.
So what I do is, I think this is good because I do this, and there is a use def edge, but there's only one. And so because there's only one, this doesn't keep things alive.
No, let me back up again. If you're defining a call site, why do you have a return?
Okay, so that I can across.
At a call site, there's no body. There's no body of the call.
That's right. So this part here is the function that I'm calling. And this up here is the caller, sorry. Yeah, so
an increment is probably in the body. That's the body.
It's in the body of after the call.
Oh, it's after the call. That's just a post call piece.
This is the post calls, this is using the call.
Yeah.
So when so basically I go into this mode, and then, you know, if I want to do some resolution without even inlining, I end up with stuff being inlined anyway before I even start doing inlining. So for instance, if I have call sites where one of the arguments ends up being constant, or it's not used in any function,
Okay.
where,
hang on
where I'm
again.
calling it, I can get rid of it even out of the
Yeah.
function that I'm calling.
Okay, so back up. Wait. So you're mixing two things, and I'm getting confused about how you're mixing them. The two
Sure.
things you're mixing are, I guess there's almost three things. There's a call site, which would be what I'm calling a lambda for the lambda calculus, an apply for the lambda calculus.
Yeah, so this is an apply.
And an apply site has a function which might be a variable, that an expression that evaluates to many functions. The one call forks out in all directions to many functions.
Yes, it could.
Okay, so hang on. And it has some arguments, obviously, and then there's a return. Then you have a lambda, which is a function which takes calls from all over the map into itself. It's called from many places. So you have an m by n fork out, fork in operation.
Yep.
Okay. And then and what I'm missing here is,
so if this is n by n, then this ends up being a compose select as well, this edge.
Okay, so hang on, yeah. Right. So I'm very, like, the return back to the call for me is a little odd. When I do a single compilation unit as a single function, there is never an apply. I'm just doing the lambda portion.
Yeah.
It has applies within it. Those are either inlined already manually by doing bytecodes, or they're not inlined.
Yeah.
And I never deal with a call going to a lambda that's two separate things. I do that in AA, not in Java.
Yeah.
So in AA, when I do this operation you're talking about, the return, I don't plug back into the apply. I make a call return node and a call epilogue.
Yeah. I thought about making a separate node here on, like, that's the call epilogue.
Yeah.
But what I do instead is, before I schedule, I break up these links that go across functions, because otherwise the scheduling gets all screwed up.
Yeah.
And I turn it back into this. It looks more like a normal call.
Okay, I leave it as a classic USDF edges. They have the same semantic meaning. It's just that they happen to cross call boundaries, and I don't care about call boundaries all that much, as in this kind of a context.
My scheduling all broke. It goes totally haywire because there are blocks that get pulled in one direction that don't get pulled in the other direction. So
well, right. So the fees will, if you claim lambda variable names, the variable names for the function arguments, the formals are fees. They might also have formal names, but they're fee functions. Then that prevents motion one way, and you get merges at the other way. It prevents motion, but you can cross call boundaries here. I dealt with it by letting the code motion sort it, except that most things are pinned. They don't get to cross call boundaries in the graph formulation that I'm using.
So I started doing that, and I had a lot of special cases, and I realized it would be a pretty simple pass, and I just got rid of the cross call boundary.
Well, I think you have a different semantic and edge layout, because I didn't have this issue.
Yeah. Well, see, I get rid of these and I move these edges back to where you normally.
So I claim that you shouldn't have selects on the call, because the call should have argument edges pointing to your 1 and your 2.
Yeah.
The selects go in the lambda body, because that's taking calls from all over the map.
Yeah, there would be many selects, right? It might have a select from this guy and another from some
Have a
other.
select from
caller.
every call which reaches that function.
Yeah,
If you're doing, you're basically building a call graph right now,
yeah.
not a control flow graph, a call graph.
Mhm.
And the call graph has got calls that lead to functions and functions that return to calls. Okay,
Yeah.
fine. Now you get an
It-
edge in the call graph from every call site to every function the call site can reach.
Yeah.
Correspondingly, that edge in the call graph turns into a select for every variable along that call graph edge. Yeah, you get a bunch of them if you have a densely interconnected call graph.
Yes, yes. So it would turn into a lot of nodes.
Yeah.
But it seems like any normal peephole optimization stuff would work right across those.
It does.
And
So you say it turns
kinda
into a
cleans
lot.
up
If
my
you have a
argument.
precise call graph, it's not a lot. And and you can peephole, and I do peephole across. Yeah,
yeah,
that counts
So,
as
like,
like partial inlining games and shit like that.
yeah, exactly. So it becomes kind of partial inlining. And so in this example, if I did the peephole optimizations, it ends up fully inlined.
Okay.
And then and then in this situation, okay, imagine that I'm not doing the peephole optimization, and then how do I get out of this mode and then back into something that I can actually schedule? So this, I kind of like it, and I was pretty happy with it. So I just kind of want to show it off.
Right. Okay. I was confused because select is up by your call, but it's because you split select from compose. And the
Yeah.
selects are, in fact, float up to the edge that leads to it. So that's the correct thing. So
Yeah.
I claim the arguments to the call can just be arguments to the call, just their standard diffuse edges.
Well, that's what they are.
Because of your select game, they're actually, you want to take the arguments to the selects.
Yeah, that's right. So I keep track of where they come from, but I at first I had diffuse edges here and here, but then I realized that I would be keeping things alive. So I have this like non-diffuse edge that just stands in, and then it allows me to go back.
How do you build your call graph edges?
Right here. So I
mean, in the general case of I have first class function arguments, I don't know what my call graph is sort of precisely without some sort of heavy duty analysis. In the case of like old school Fortran, I 100% know my call graph because I only have static calls.
It seems like, because I have these constant things which are function ref gadgets, and so there can be multiple of those, and there could be a select, like a compose select that's pulling in a few of the call.
A call to a variable, what it amounts to, the function variable.
Yeah.
Okay, so now you don't know your call graph except imprecisely.
Yeah.
Because you don't know what the contents of that variable are, so you don't know what function it calls.
Yeah, that's right. And I think I've got one of those here. It gets a bit more confusing, but here I call and then compose, and I've got this function or that one.
Yeah, I'm hearing you. So I went through this in AA some time ago, and I have a lazily construct an efficient call graph so I don't have to inflate the bad case and then analyze away 99% of the dead edges. Separately from how you make it efficient, your compose game for me says what I'm seeing on your call is you have you have the same value being flowed along the same direction under two edges, and that's an issue for having redundancy, department of redundancy. Your call args and your selects. So call args are known from one pass over the call directly, easily. When you add a call graph edge in, and you want the call graph to be wired to the known target, because somehow you know the target, because that's a call graph, then you want to do the select compose, and I claim you should ponder moving that call from I take my arguments to I know all my targets. They all have their own selects. I don't need any arguments anymore.
Yeah, that's what I do.
Okay.
So
well, there you go.
So basically, so what these red edges are not use def edges. They're just
This is where you-
different edges
Yeah.
that just allow me to, so I need those useDef edges to come back when I go back into scheduling mode. And so, and maybe some of these are going to be gone,
Well,
but
if you're scheduling and you have selects, you could at that time use the selects to push them back on the call. Like
yeah,
if the argument went dead, because the function, all targets of the function have the argument known dead. So you
Yeah.
want to go back to the call site and say, oh, don't compute this argument, it's dead.
yeah. So if that's the case, then then this, say the 2 turned out to be dead here, then
Yeah.
it goes like that. That
But-
edge goes away too.
But no,
And
the
that
2
way-
won't go. The only reason the 2 goes away is because the red edge doesn't count as a use. You have a red edge from the call. to
That's
the
right.
2.
That's right. That's
Okay.
right. The red edge doesn't count as a use.
And what I'm saying is,
Until-
don't have any edges that don't count as uses. Just get rid of them.
But I want it to go away, right? Because
Yeah, get rid of the red edge. Go put the
Yeah.
2 back. Put your selecting your 2 back. Hit undo on your editor.
yeah,
Yeah. Okay. Get rid of the red edge from the call to the 2. Like when you're in the zone where you have wired the call up to all of
Yeah.
this, you built the call graph. You don't need those red edges. Get rid of them.
well,
So now the dead code elimination works just as it did before. It's all on nodes. It's all fine.
yeah. The only problem is that I won't be able to tell where,
You will.
say I could have 2 calls to this function in the same thing. I won't be able to tell where the arguments come from when I try and do this.
Then your select is in the wrong, and in fact, then your select's in the wrong place. The second
Well,
call,
I know which region the arguments are in. I just don't know which call
the
they're in.
call, okay, yeah, the fix here is the call now starts a new region. It has a control output. It has a return value like an int. It has a control value, has a state of memory. It has to have a control because it
Oh.
is not legal to bypass the call with many things like stores. Side effects are not allowed to bypass the call. So the side effects have to be pinned behind the call. In the
Oh,
land
so
of Java,
you actually
things-
end a block at a call as well?
Basically, it does. So I don't declare blocks when I go to the sea of nodes. But effectively, a call makes a block boundary. Things that are completely in values can float around the call. Things that have side effects like an array index out of bounds exception, a null pointer exception, a store to memory, they all get pinned by the call.
Oh, okay. Okay, yeah, that was actually something I always found a bit odd about basic blocks, that calls lived right in them and you could actually jump in and out of the middle of a basic block. But I was just going with it.
Well, yeah, you went with it. And then, of course, you knew that stores couldn't slide up past the call. So immediately
Think about that, actually.
2 ads of unrelated shit can, the ads can move past the call, but the stores cannot. Why?
Yeah,
It's a basic
but
block.
so I made my call tied to the store anyway. So like here, this one actually, I have
But
this
now
example.
put a second store after the call. What's it tied to? It should be tied to the call's output memory state.
Yes, should be.
So therefore, a call blocks stores, blocks memory state is a minimum. It blocks control flow changes that happen when the call itself, say, infinite loops, or throws an exception, or whatever.
Right.
Yeah. So
If I have a store in a call, do I need to have another one
I'm
that's
saying,
coming?
as an example of what you need to sort on, that second store that follows the call needs an edge from the store to the call. And therefore, call is producing 2 values in your graph right here. It's producing a memory state that the store wants to mutate after, and it produces a normal return value like an int or a float or whatever the normal return is. Now
Right,
make it
and
return a third thing.
that's why you've got a projection here.
Yeah. And the third thing it returns is control. It returns, it's a basic block effectively. Yes. It returns a memory state, it returns a control state, it returns a value state or a value thing. That is, for me, calls return a tuple, and the tuple is control, memory, value.
Right, right.
And now your other problem of which select goes where goes away because it's pinned behind the second call and you can tell.
Right, right.
And that took us 15 odd plus minutes and we're at 3 hours. So I'm really,
Yeah. Okay. Well, thanks. That's good because that's something I didn't think about.
yep,
Cool.
that's great. All right. I'm off for 2 weeks. If I magically have a great internet connection and my time zone's not completely wazoo, but probably not. So I'll announce but don't expect one.
All right.
And then back in 2 weeks, and I think I'll be on again after that. So I don't know when that date will be. Whatever. All right. Next time then, till we see you again, meet again. Bye-bye.
Uh,